Alrighty, let's get this show on the road. Good morning, everyone. I'm a little early, so I'm just going to say hi before I kick into official content and stuff. And before I get going on the stream, just make sure that everyone can hear me. Just ping chat if you can hear me okay. Otherwise, I'm just talking and the microphone's not picking up anything, but we'll see how we go. Someone said nice haircut. Do I know you already? Have I met you before? I don't know if you've seen what my haircut looked like. This is me coming out of quarantine and actually getting a haircut, which was really nice. So I figured that's a nice start to term 2. Alright, I'm getting a whole lot of yeses in chat, which means that you can hear me okay, which is a good start. Let me just knowing that, like, once I get going, you're going to want to see the slides more than my face. As much as I love everyone to see my face. Okay, we've hit 9 AM. Let's get started. So this is one of the differences. Yes, someone's noticed that there are Gundam in the background of my room here. There's a couple of old Transformers and stuff like that as well. Oh no. Tom is joking, by the way. I am not a professional live streamer. I am actually a professional university lecturer. You don't have to subscribe to this channel or anything like that. The links for all of these lectures will always be available on our web CMS, on our course website. Hopefully I've got links in the lecture to that. I'm just trying to remember if the links in the lecture I've updated them to 20T2. I know because I recycle some of the slides from last term. People are asking where Chicken is. If you haven't heard of someone called Chicken before, Chicken is my cat, and Chicken got really famous last term for just kind of turning up midway through lectures and saying hello and things like that. I'm just looking down the corridor to see where she is. I can't see her at the moment, but I've left the door open so she can get in, and we'll see how we go. Someone saying that your maths lecturer has a Twitch channel. Well, I mean, look, I had the choice between Twitch and YouTube Live, and I picked YouTube Live because I thought it sounded a little bit more official. Someone's saying, is that a Devastator on the shelf? It is. It's a, what's the company? MTC. So it's a non-official Devastator. If anyone else is interested, that's like someone's pointing out the Transformer in the background there. Anyway, enough unofficial content about me. Let's get into the actual. I mean, I am probably going to introduce myself in the lecture as it is, but as you can see, I've got my shelf of some of that stuff is toys back there, and so you can see some of that. Okay, everyone's loving my new emo fringe haircut, so like maybe I should like really get this going. In case you're wondering, when I look in that direction, that's me looking at my other monitor. I've got a weird setup at home where the monitors are actually pretty spread out. So if I'm looking over that way, that's me looking over the chat to see what's going on. Alright, let's roll into the content itself. I mean, I think one of the nice things about streaming this stuff is that usually when we're live at UNSW, as much as we'd like to be live at UNSW, because that's also fun, streaming lets me start earlier, because usually a lecture recording doesn't start until 5 past the hour. So this means that I can get rolling before 5 past the hour, and I can go a little bit beyond 5 to the hour, knowing that I'm pretty sure none of you need the walking time right now to get between the lecture theatre and your next class if you've got a class after this. So things are a little bit things are a little bit weird and different. This is the first term ever that we've run COMP1511 entirely online, so there'll be some different difference in what we do. I mean, this is actually the first time that I've had the chance to just sit here and have a chat with some of the students before the first lecture even of the term. I actually used to do this thing because, as you can see, I don't really look my age, and so a lot of students have a thing where they confuse me for another student. And so I used to do this thing where I would actually sit outside before the lecture began instead of going inside and prepping my slides and stuff. I would sit outside and hang out with whoever was there at the time and just talk to people, and then like later on when we all walked into the theater and I walk up the front and everyone else doesn't, it's like they all just got really freaked out. So it's kind of funny. Alright, we have one question there. How do we know which lab and tute to join after this? Tom, are you there? Maybe Tom can take that question. So Tom and Michael here are both in the chat. Oh, Michael doesn't even work for this subject anymore, but he worked for this subject last term. You can keep your moderator status, Michael. It's always useful. Yeah, so Tom will be here to answer a few questions and things like that. Okay, let's get into the lecture itself. So, what are we going to talk about today? Let me just make sure my face is not covering up any of the slides. In fact, I might just move myself up into the top corner there. Thank you everyone for braving the weather and coming out today. For those of you who aren't in Sydney, because I know that we actually have a significant number of people who aren't in Sydney now for the lectures, it's entirely unpleasant outside. It's just grey. It's raining every now and then. It was raining heavier a little earlier, and it was just generally not a nice day. So it's a great day to stay indoors, take your lecture from home, maybe take your tutorial and lab from home if your tutorial and lab is on today. We've got some people asking questions about when it happens and how it happens, and Tom's going to give you a bit of information there. On top of that, I think most all of the tutors have emailed their tutorials now to let them know exactly when it is and what link to use to connect to our system called Blackboard Collaborate. Blackboard Collaborate is like, I don't know if people have already been using stuff like Zoom and Teams and Discord and all that kind of stuff. It's just another one of those programs that allows us to teach remotely. The difference for us is it gets you to log in with your student ID so we know who you are, and has some things where we can split up the classroom to do group work and stuff like that. So it's like just handy for that reason. So, I mean, it'll be pretty familiar if you've been doing any kind of hangouts with friends and stuff on video chat. It's going to be a pretty similar thing. So it's just like you're doing a video chat, but this time there's a teacher in there who's going to help you go through content and help you with all the stuff that we're teaching in the course. Let's get back to the content itself. So, alright, I'm going to let Tom handle the chat there so I can just get into the flow of what I'm going to talk about here. So, today I'm going to introduce you to COMP1511, which the course is called Programming Fundamentals, and it's about learning how to program from scratch, in a sense. So I know plenty of people here have probably programmed before. There's a much bigger push nowadays for people to get a significant amount of programming literacy in high school. So this is usually the point where I would be looking out for people to put up their hands and stuff if they've programmed before and stuff like that. I would ask people to type in chat, but then I'm just going to get flooded in chat because there's over 100 people in here at the moment, so I won't necessarily ask people to necessarily talk about it. But I know that people are probably have seen a little bit of programming before. You may have seen things like JavaScript and Python. I think those are the languages that a lot of people start with. We're going to be using a language called C, but I'll get into that a little bit more later. So today, split into 2 hours, 2 separate hours. We'll have a break in the middle. I'm always going to have a break in the middle. I don't really like people to have to try to concentrate for 2 hours straight. It's not super correct for the human brain to actually be able to do that. So the first hour is a lot of what you'll get at the start of any subject at university. Is like, okay, introductions, I'll tell you about who I am, although I've already got my bookshelf of glory back there to show off with. But I'm going to talk to you about how the course works, and so all the little details about, you know, what kind of work are we going to do in the course, what are the assessments, how much they're worth. Everyone wants to know how many marks stuff's worth, because, you know, at the end of it you want to get your marks for things, and how we want to approach learning about programming. And in the second hour I want to give some background on what theoretically a computer is and how to understand what a computer is. And we're going to look at C, which is the programming language we're using, and we're going to look at Linux, which is the operating system we're using as well. So there's a bit of both here that's going to give us a bit of a first look at the systems that we're going to be using, and they're probably going to be pretty different from some of the systems that you may have seen before. Usually I would now scan the lecture theatre and see how many Macs and how many PCs there are there, split everyone into two sides and force you into physical combat to decide which one is superior. No, I'm kidding. But I would at least talk about that kind of thing, where most people are used to using Windows or OS X, but we're going to be using Linux, because Linux is something that is actually very prevalent in the computing industry because of its flexibility and the interesting things that people can do with it, because it's an operating system that can be customized much better than others. I'm also going to talk about exactly what an operating system is. So anything that I'm saying that for the moment the words are like, what does he mean by that? We'll get there. You know, I try to most of the time not introduce terms that I haven't explained, and if I do so, I'll try to make it clear that we're not jumping into something just yet. This is an introductory course, which means I'm going to tell you a whole lot of things about stuff that you don't know yet. But if you do want to continue in something like computer science or any of the computing degrees, or your own degree is something very technical and you're going to learn more about it, then I'm going to give you the grounding to continue in those things. So while I'm giving everyone their, possibly, like, it might or might not be your first taste of computer programming, I also want to give everyone a kind of a launch pad, so that if you were to continue in computing, or heaven forbid you were to transfer your program across to computing from whatever you're in right now, I would never complain if that happens. Then I've set you up to start a computer science degree or something like that. Someone's asking me if I can speak 2 times faster. I have a feeling that seeing the number of people who are enrolled in the course and the number of people who are currently here in the stream, that there's plenty of other people who are planning to do this in 1 hour, or, you know, what would be even like 2/3 like of an hour later on today, but we'll see how they go. Oh, we've got a couple more of the tutors in here answering questions, which is great. Okay, cool. People are enjoying my pace. Okay, that's fine. My pace is the plan for the 2 hours, that we will get through the 2 hours of me talking at this speed, rather than me talking very fast and then this kind of thing. And then I can actually think fast enough to speak at 2 times speed, so I'm not even going to try. Okay. Someone's asking, Lee's asking if this will be recorded. This is being recorded. YouTube Live records things automatically, so this will stay on YouTube. I'm also organizing with the university for me to be able to upload a separate recording of this somewhere else, in case people can't access YouTube. I'm sure there's plenty of people who are not here right now because they don't have access to YouTube, or they don't have an internet connection that can handle streaming, and so we want to make something available for them as well. There's my face. It's covering up my face, which is quite funny. Alright, I'm just going to move that there. Okay, so who's teaching you? COMP1511. If you haven't noticed already, my name is Mark Chi, and this is a photo of me, which is quite funny because there's another picture of me in the bottom corner as well. If you need to get in contact with me, there's this email address which goes to me. It's cs1511@csc.unsw.edu.au. That email address doesn't just go to me, it also goes to Tom, who is in the chat at the moment. He's the subject admin, which is good because there are a lot of you. If I gave you all my personal email address and said, hey, just shoot me an email, I would immediately have 700 emails in my inbox, more than 700 at the moment. I think there's 740 people enrolled right now. So as you can guess, there is no way I could actually survive that level of inbox explosion. I have enough trouble answering all the emails I get as it is. I don't know if any of you have sent me emails in the last couple of weeks after enrolling or anything like that. I apologize if I haven't answered you. Chances are it's because I've got hundreds of other emails to deal with. It gets like that. So you'll find, depending on how many people are in your class, that's usually a measure of whether your lecturer can actually reply to everyone or not. So I've got this email address instead, so that Tom and myself can actually filter things in a sense and just say, okay, these things are super urgent, and then we'll reply to them or not. Or if anything happens to me, I get busy, I get called off to do other work, then at least there's someone from the course watching that email address. So please don't email my personal email address, which you may have found through one place or another. I don't publicize it in the course. If you're going to talk to me about the course, it's the CS1511 email address. We have a whole lot of tutors for this course and a subject admin. I mean, it's actually easier to introduce people like the tutors and the subject admin because now that we have live streams, a lot of them tend to turn up in the streams. I can see two of them are already here. Tom, the subject admin, and Shrey, one of the tutors, are actually here in chat right now. So obviously bored or not much to do, felt like getting up for a 9 a.m. lecture. So a lot of fun. Yeah. Alright, I won't spend too much time reading chat. Oh, Alvin's here as well, so one of the other tutors is here. You may be meeting these people in person, online in person, sooner or later, but it depends on who your tutor is. I'm not going to mention everyone because there's 30 or so people working on this course. That's how many people we need to cover the number of people who are taking the course. I'm not going to mention them all in person, but they're all great people. They're all hand-picked teachers. Every single one of them is an undergrad student as well, and we do that on purpose so that the people who are teaching you, so you've got someone like me teaching you who's a bit more distant from you in terms of actually understanding the experience you have as a student. And so we hire undergrad tutors who may have done this course. Some of them, not many, but some of them even just did this course last term. Some of them did this course a couple of years ago or so, it just depends. And so they have a really good understanding of the course as it stands now and what it's like to be someone studying this course. And I feel like that's quite a valuable thing to have as a teacher. So those are the kinds of people who are going to be taking you through your tutorials and labs. So they're going to be seeing you nearly as much as I am. So you're with me 4 hours a week and you're with them 3 hours a week. The course webpage is here. It's on a system called WebCMS. Feel free to go through, have a look. There's not much content there, but the content will grow as time goes on. So basically, I will unlock lecture content every week for this, and we will unlock tutorial and lab content every week for this, and just sort of expand it as it goes along. I specifically don't want to have all of the content for the course available from the very beginning, because I see that tends to kind of, I mean, like if I was to try to brain dump for you the entire course at the very beginning of term, that's the kind of thing that sort of blows people's minds. So I like to release it as it happens instead, and so there's actually a kind of a narrative going through, and I can say, okay, I think some things ought to be learnt before other things, so I don't necessarily want everything to be available at the beginning. If you really, really want to, there's a 2020 Term 1 website, which you can actually find by just changing that 2 to a 1. You can go have a look there if you want. Not necessary at all. This is only if you really want to jump ahead and scope out what the content's going to be like. Considering we haven't wrapped up the 20T1 course yet. The admin remaining for the course is still unfinished. We've already started 20T2. I haven't changed the course very much between the two. There will be changes as we go through, but it won't be a hugely different thing. And if you really want to, I don't know if anyone's like super keen, this YouTube channel has another playlist, which is the 20T1 playlist. And that actually has all of the lectures I delivered for 20T1. So if you wanted to, you could watch them, but you don't have to. Like, if you want to, you can just take the course as I'm delivering it. It's kind of like, do you want the exact narrative the way I deliver it, or do you want to go and look up spoilers? So you can look up spoilers and go, Mark's going to talk about this next week. And it's like, yeah, okay, cool. You're really cool. You found spoilers. But if you want to, you can just follow it as I deliver. There's a course forum as well. You should have received an email about this. If you can't find that email, this is a good email to email and say, hey, I'm not getting any of the course emails. Because if you haven't got any of the course emails, like the course notices from us, then there's an issue. We're going to send them to your UNSW email addresses, and that is going to be the place where usually about once a week. It'll get more than that when there's assignments out and other things like that. I will ping you with an email once a week and go, okay, this is what we're doing this week. So I've already done that. I did that on Sunday. I can't remember if it was Saturday or Sunday. I think it was Sunday afternoon, Sunday evening. I sent out an email to everyone saying, okay, this is how the first week's going to go. Here's a few links. Obviously, everyone who's here right now probably was there because that was one of the only ways to get the link to this lecture as it is. Okay, so these are a couple of things that you should get into, checking out the website and the forum, stuff like that. One of the valuable things about the website itself is you can actually get the slides that I'm going through right now. So if I go too fast or something, you can probably skip back using a PDF of these slides itself and just see how things are going. Oh, before I continue, I completely forgot, because I always forget this at the start of term. Before we go any further, I need to acknowledge the Bedegal people and of elders past and present who are the custodians of the land upon which UNSW sits, which I'm pretty sure very few, if any of us, are at UNSW right now. But I figured it was probably a good idea to acknowledge the traditional owners of the land, regardless of whether we're on that specific land or not. You may be on a different nation's land where you are right now, or some of you are overseas, and this is just an acknowledgement of the native owners of the land. If we'd all been in the same place, this would have made more physical sense, but still something I think that's important for us to acknowledge. Okay, so welcome to UNSW and welcome to programming. I don't know how many people this is a welcome to UNSW for, because not everyone is starting their degree right now in term 2, but I'm pretty sure plenty of people started their degree in term 1 this year, because this is a course that is always a majority of first year students. I mean, there's always a few people taking this as an elective to see what it's like to do programming, but I always like to treat this as something that's like, okay, let's talk as if people have never seen university education and they've never seen programming before. So I want to talk about what it's like studying at university. Wait, someone's saying my meme game is stronger than semester 1. This meme is in semester 1. This is the meme that has the most risk of me becoming this guy. Hey, fellow kids! Yeah. Just pretending that I'm younger than I am. Who scare me is like significantly older than me though, so don't worry about it, it's okay. Okay, so I want to talk about what it's like to study at university, because usually what I would do at this point is I would try to get a show of hands of how many people came straight out of high school last year, and I'm just going to guess because I'm not going to be able to get a show of hands. But usually it's about, I don't know, 70-80% at least of the lecture theatre. So I'm gonna talk as if it's that. I always make this joke about high school, that high school is kind of like prison. Like, high school in Australia has a habit of really institutionalizing people, like really getting people to think that like everything's regimented into these hours, and it's all like just do exactly what people say. University is really weird and different, and so the transition from learning in high school to learning in university can be really jarring for a lot of people. But it also is really interesting because it gives you this level of freedom that didn't exist in high school. So, for example, I have 113 people viewing this stream right now. Someone's saying straw poll. Oh, I should set up some kind of poll system here so that I can get like that kind of show of hands thing. I mean, that would have been valuable to set up before today, but we'll see if I can do it maybe for Thursday or for continuing onwards. See how many windows I can fit on my other screen over there to watch what's going on. Like, I've got the stream and the YouTube live stuff already happening. Okay, so talking about university, and I was saying that I've got 113 people in the stream right now, and this is very different from what I'd expect if I was teaching in a high school. I mean, if I was teaching in a high school, I'd only have like 30 students at a time. But I would expect them all to be there, and if anyone wasn't there, then there'd have to be some kind of significant excuse or reason why someone isn't there. Whereas here at university, we're free to use the content as we like. So I'm expecting a significant number of people to watch this video afterwards, but not have to turn up at the time, because a live stream is not something that you have to take part in. And plenty of people who are watching this in our future, so they're just watching it when it suits them, and knowing the general sleeping patterns while we're all in quarantine and lockdown at the moment is people are probably waking up at midday after having gamed all night or programmed all night and practiced their C. We'll see how we go with that. So the interesting thing I think about studying at university is you get this freedom, but with great freedom comes great responsibility. It's not exactly the right quote. We get into a situation where you're in control of your own learning, and that makes things really interesting. So if you don't turn up to anything in COMP1511, I'm not really going to know, because there's over 700 of you. So there's no chance that I'm going to tap you on the shoulder and say, hey, where have you been the past few weeks? Are you okay? Is everything working out? We kind of need to make sure you're here so that you learn these things. We don't do that, because you're an adult now and you're fully in control of your own education. Apologize to anyone who is, an actual mature age student who doesn't need to hear this. But I still think it's important for me to talk about this. So what happens is, with the freedom to control your own education, you also have the freedom to potentially screw it up. But, all screw-ups can be dealt with as time goes on. The other thing about it, which is really interesting, is if you hate it and everything's boring and everything's not working out, UNSW is a really big place. UNSW has so many different fields of study. I don't know how many degree programs there are at UNSW, but I'm thinking like maybe 100, 200. I have never counted them. When we're in a situation like this, if computing is not what floats your boat, there's going to be something else you can find. The thing I used to say when we were in person is you could walk outside the lecture theatre and throw a rock in a random direction. Don't do it. But you can, and you will hit a building where someone is studying something else. Someone is studying something amazing and different, and that might be the path for you. And it's quite easy to shift between paths because you actually have control of your own education now. So you can go and sign up for film studies. I feel like A lot of people are kind of doing a major in film studies at the moment, and very few people are majoring in sport because it's all kind of in lockdown and most team sports have stopped working. But there's plenty of time to watch TV and watch films and stuff like that. So, you know, there is this kind of freedom that you may not have had before. And so there's this back and forth with that, right? So you've got this freedom, you can do all this cool stuff, but at the same time, you will be now responsible for everything that you're doing. So I'm not going to push you to do all the work for COMP1511. It's up to you whether you do the work or not. I'm going to give you marks if you do all the work, and you're going to get different marks if you do the assignments and exam well and stuff like that. But it's not up to me to decide how much you should do. As this is a university course, you can do about 50% of the work in the course and you can still pass the course, and that's enough for me to say, yes, this person has the capability to do this. I'm going to talk about exactly what that 50% means as we go through the course itself. So I want to talk also about what programming is, and this, after this long, is actually what I'm talking about with this meme here. I like to think about programming. This is the way I like to explain it to people, especially to people who have never done any programming before, is programming is talking to computers. So I've got my computer here, monitor over here, and stuff like that as well. And if I was to say to my computer, hey computer, I want you to create a program that will teach all of these students how to do programming in C, because that's the thing I have to do over the next 10 weeks. And then you might be asking, why is he talking to his computer, and what effect might that have with my computer? Well, I've just said it, and my computer has done nothing. And that's exactly, I guess, how that sort of works at the moment, because I've spoken to my computer like it was a human. And that makes no sense. The computer did not listen to what I was saying. There are some computers who can. I'm thinking of like Siri and Alexa. They might be able to tell me as much as, no, I can't do that, that's too complex a task, or something like that. Or they might just say they don't understand what I was saying. So one of the issues that we have is, if we ask a person to do something, then we have a shared language. So most of us speak English. I hope everyone has a reasonable grasp of English. It's okay if your English isn't that great. You can always watch this again and slow it down if you need to. But UNSW, being an Australian university, is going to teach everything in English. And I apologize for those of you who are in the US or other countries. I know that there are some people. We're doing it in Australian English, so if there's any time where I say something that has a weird connotation or something that doesn't entirely make sense, feel free to just ping me in the chat. And oh, sudo make a sandwich. Someone's been on XKCD, haven't they? I've just saw the chat. So if there's anything you don't fully understand, just ping the chat, and hopefully one of the tutors will be in there, and they can give you a pointer on what I'm talking about. So if I talk to my computer and nothing happens, it means my computer didn't understand me. So what we then need to do is we need to have a language that humans can understand and computers can understand. So computers understand very particular ways of doing things, and humans understand really particular ways of doing things as well. And there's places where we can find middle ground between the two so that we can communicate. One of those places is C, which is a programming language we're going to talk about, and most of those are programming languages. So most of those are situations where we can ask our computer to do something by giving it a program, and it can run the program in the way that it sees fit. So we talk in a particular way to it, it understands things in a particular way, and we kind of meet in the middle. So that's one thing about programming, is just getting the computer to understand what we're saying. And that's one thing that we're going to work on a fair bit. That's one thing you can get better with practice, which kind of everything is getting better with practice, but you know. The other thing is, we're going to be using programming to solve problems, and so we're going to learn about solving problems. I'm going to devote a fair bit of time into how to pick apart a problem and then translate it into computer code and then type it in and get it to run and things like that. And then finding out why it didn't work, which is another thing entirely. one of the interesting things about the way programming works is, as opposed to really explicitly telling our computer what to do, we have this understanding that the computer is not a dumb object. It is not something that is there to just simply do exactly what we have programmed it to do. It's there to react to situations that it finds itself in. And so we're going to give our computer the capability to make decisions as it is doing what we've asked it to do. And so a lot of that comes down to the way that we might ask our computer to get the answer to a question. But instead of telling the computer what the answer is and saying, okay, just deliver this answer to the question, we say, okay, here's the question, here's a procedure we've come up with which to find the answer to that question. Now you carry out that procedure. So we give a certain amount of autonomy to the computer itself, and we ask the computer itself to be able to calculate things on its own and to be able to actually think for itself, at least to a certain extent, to decide how it's going to approach the problems that we give it. And yes, we would all like to now pledge our allegiance to our robot overlords before they take over the world. Alright, that's my little preamble. Let me just move my face out of the way again. As you can tell, these slides were built initially not for live streaming and not for needing a little space for my face here. But I'll just keep moving that around as I see it. Okay, so let's talk about logistics. Let's talk about the course itself and how it's going to run. We're going to teach you C programming, but not just C programming, but how to think about programming, how to do problem solving, and how to do problem solving specifically with the intention of writing code to solve problems. That's the overall idea of what we're going to teach. And the bits and pieces that make up how we're going to teach are reasonably similar to everything else that you get in a university course. So we've got lectures like the one we're in today. We have live streams, and usually they would actually be distinct from lectures, but now the lectures are all live streams. But yeah, these will be separate, and the live streams will be scheduled at different times, and there will be optional content. So whether or not you come for the unofficial live streams is different from whether you view the lecture content. We're going to assume at the end of the course that everyone has seen all of the lectures, and I understand. It's alright, I was a student once as well. Not everyone's going to watch all of the lectures, but pretty much everything that's in the lectures is going to be useful to be able to solve all of the problems we're going to put forward to you in assignments and in the exam. So, up to you. As I said, you're in control. You can choose how much of this you need. We've got tutorials and lab sessions. Plenty of people have already been in tutorial and lab sessions because they started yesterday. If you were scheduled yesterday and you didn't realize that the tutes and labs were running this week, feel free to turn up to one of them later in the week. So you'll notice if you go to the links on our Moodle for Blackboard Collaborate, you should actually be able to see all sessions during the week. This also is a general sort of thing where if, say, you're sick on the day that you have your tutorial lab, or you were called away and you're busy and you had to do something else, we don't mind if you sit in on another tutorial lab. You just need to let the tutor of that particular tutorial know and just say, look, can I sit in? Because often there will be there's a limit to how many people that someone can teach at once and teach effectively, so we don't want to overload the lab, so it's nice if you have the courtesy to ask before you join a random lab. We have weekly tests and assignments. I'll talk about those later. So I actually have slides for all of these, so I might just jump into the slides and talk about them. So the overall schedule, some of you will probably know this already because I think the majority of people were studying already in Term 1 in this course, but there's plenty of people who weren't studying in Term 1, so you may have just started your time here at UNSW, we run a 10-week term. So we're currently in week 1 of 10 weeks. Week 6 is known as Flexibility Week. So Flexibility Week means that it is flexible for you, which means if you want to, you can be here for that week or not. So it's an idea that week 6 is a kind of a reprieve, it's a break so that you can just sort of recharge a little and then hit the last 4 weeks of the term with a fresher mind. So a lot of the course doesn't run in week 6, and anything that does run in week 6 will not necessarily introduce any new content. And if it does introduce any new content in week 6, it'll be optional. So it'll be things that I think are useful, handy, but not entirely necessary. I will probably still be running lectures in the same time slots, but no tutorials or labs will be running in that time. We will potentially have some guest lectures coming on then. Just remembering, as I was talking about emails, I need to talk to the other lecturer who often comes in week 6 and delivers some content, and we'll have a chat about what might be delivered then. We still have assignment due dates around then, and we'll still run things called help sessions. I'll talk to you in a sec about what help sessions are. Okay, so I'm going to go through the content, talk about what it is. Lectures. You may have figured out already what a lecture is because you're in one. A lecture is a way for me to deliver a great deal of information in a short amount of time. That doesn't mean this information needs to be fully digested immediately as I say it, because I think that asking someone to have that level of understanding is a bit much, which is why the lectures are recorded. You can go back and play them again. So I've been given a limited amount of time to deliver a lot of information to you, and so I'm going to be delivering it pretty fast. Don't worry if a lot of it goes over your head. A lot of it is actually designed to sort of go over your head the first time. So this is just stepping aside into like the theory of how to teach people. So how to put ideas into people's minds. Is that the first time I introduce something to you, I don't really have a huge expectation that you're going to understand it. The second time I introduce something to you, I have a decent idea that a lot of people are going to recognize it. Maybe the third time I would present something to you, I'd expect the majority of the class to then get a grasp on the concept. Which is why we have things like tutorials and labs. So they give you your second look at everything that I'm giving you first look at in lectures. There are some parts of this course that are specifically designed as your first look at something that we have no expectation that you will have a full grasp on by the end of COMP1511. But we consider them to be very important topics for people to know about if they're going to work with computers long term. So I'm going to talk a little bit about like the physical structure of a computer, not that much, but a little bit. I'm going to talk about the theoretical structure of a computer more than the physical structure. But those are things that open up pathways for you into learning later on if you want. And so I like to give people their first look so that if they hop into another class later on in second or third year to continue computing, or if you're in a computing degree, right, next term immediately you'll be hopping into more computing courses, you'll have seen some of the concepts already, even if you didn't fully understand them. So the lectures are a lot like that. There are a lot of the times I'm going to give you your very first look at something. The other thing I am going to give you as well is in lectures I'm going to do stuff like live demonstrations of things. So we're going to actually do that in the second hour today, where I'm actually going to do some code live. It's not very much. Right, we're just going to introduce what code is today. We're not really going to write that much, but at least you'll get to see the fact that I go back and forth between theory and a bit of practical. I'm happy to answer questions that come in live chat, but again, time is of the essence. I tend to go over time in my lectures as it is, so I won't even look at chat a lot of the time. But some of the tutors are in there and they can probably just be rolling through answering your questions if you have them, which I think personally is like, I said this, like, I was talking to some friends about like who caused the COVID-19 pandemic, and I mentioned that I had said quite loudly around UNSW last year that live streaming was a superior form of delivering lecture content than live lectures. And so a few of my friends have said that I caused the COVID-19 pandemic by saying that, and now I have to live by I have to live by my idea that live streaming was going to be superior educational content than live lectures. So that means that you can actually converse with me and the tutors in a way that we wouldn't have been able to do in person. There's absolutely no way in a live lecture that I would allow this much chat to happen during the lecture. It would be super, super distracting. So this next point is slightly different now that we're in an online world, but I think it's still important. I have one rule in my classes, and it's a rule that I think you should not just follow in my classes, but in general, and the rule is that no one disrupts anyone else's education. Which means if you start spamming chat with random stuff that makes it hard for people to ask questions or hard for people to answer questions, I consider that you disrupting other people's education. So I don't mind if you find the lectures boring and you tune out and you go, right, I'm just not going to watch them. I'm just going to do all of the tutorial and lab content and hope I get everything from there. If that's what you want to do, that's your choice. I would consider that you disrupting your own education. And that's fine. Because as I said, you're in full control of your own education. But what I'm saying is you do not have the choice to disrupt someone else's education. So that means that, it's like don't talk during lectures, but like I'm saying, you can totally talk in the live chat during the lecture, as long as it's about the lecture content. It means you give everyone a chance to learn in your tutorials and labs, although I'm pretty sure your tutors are going to be quite happy if you're active in the tutorials and labs, because it's harder to get everyone to be active when we're all online. But it does mean that we make a point to not make anyone else uncomfortable during our time in these courses. There's a huge difference in an introductory course like COMP1511 about how much programming people have done before, whether people have learnt some of these concepts before or not. There's a wide range of backgrounds here, and there's a wide range of, say, choices of lifestyle. There's a wide range of cultures that people are from. None of those things are really relevant to whether you can study this course or whether you can get a fulfilling time out of learning this course. So in general, I will say that we don't we are not going to point out the differences between people or anything like that, and we don't really want anyone else to, because that kind of thing can make people uncomfortable. Making people uncomfortable will disrupt their education, and that breaks my one rule, that no one disrupts anyone else's education. So what I'm saying is that everyone's got a chance here, and I don't care where you're from, who you are, or anything like that. You get to learn here. So this environment is open to everyone, and it being open to everyone means no one is allowed to close it for anyone. All right? So simple thing, and I think that's like one of those rules you could live life by if you want to, and you would, like, in general, like, if you could follow that rule to the letter, you would end up being quite a nice person. So it's one of those little things. All right. Oh, okay. I always do this where I talk about the next slide before I actually put it up. So I was talking already about what I was going to do in lecture content. A lot of theory, a lot of like why things are the way they are, and then demonstrations to show you some code. We're going to step through the process of how I would solve problems. So hopefully they'll teach you how I will put up a problem and go, okay, let's go through how we would pull it apart and how we would solve it. And I'm not just going to talk about programming itself in like the raw sense, but also what is important outside of the core concepts of programming. How do we work as a programmer? So I have a lecture that I give on professionalism, which is usually open not just to COMP1511, but we open up to CSESOC, the society here. And we talk about what it actually means to be a human working with other humans and things. Because strangely enough, a significant amount of computer programming is not just for computers. It's actually for people. So there's a lot of how we work with other people, which we're not going to get that much of a chance to work with other people. We don't have any assignments that are group work in this course, but we do start to introduce the idea that we are going to be working with other people with code. Okay, so the lecture recordings are going to be available. Those of you who are here right now, this same link will turn into a recorded lecture link a few hours after the stream is finished, and I will also put some recordings on the course website once we set up the infrastructure. I'm talking to UNSW IT about how we're actually going to do that. I saw myself get tagged there. Tom was saying, see my earlier comment about demoing Blackboard Collaborate. Oh, you're thinking we actually run a demo of Blackboard Collaborate in the lecture? We might be able to do that. Yeah, Shrey's asking some question about the difference between live streams and live lectures. Yeah, I apologize, right? Because usually it would be completely different. It would be like, these ones are in person and they're super official, and these ones are purely online and they're less official. But now everything's online, but some of the stuff is official and some's less official, so there's a bit of a grey area there. Okay. Tutorials. So you may have already been in a tutorial, or your tutorial might be scheduled for later this week. A tutorial is, and I'm going to say this is rough now, is a 1-hour classroom lesson. It's a very interactive lesson. You can talk to your tutor during this. You can ask questions. So this is very different from the lecture. So the lecture is a 700 to 1 kind of thing. So when I have this kind of thing, I can't really get into a conversation with people because there's too many people to try to talk to at once. So lectures are going to be me talking and you listening most of the time, whereas tutorials are going to be more about Tom saying something has been confusing people. I'm not sure what you're talking about, Tom. Let me know exactly what you mean. Maybe in the break we'll figure out what you mean and I'll talk about it to everyone. So the tutorial is more interactive. We will continue what I was talking about in the lectures in the tutorials. So the usual way that I set everything up is I will talk about something in week 1, for example. The tutorials about it will be in week 2. So that means that if your tutorial is before or after the lectures in the week, doesn't matter, you'll get to do the content after I've talked about it, no matter what. There's a lot more practical stuff going on in tutorials. There's a lot more active discussion and things like that. It's not necessarily full-on coding in the tutorials. You can participate in your tutorial without actually typing anything on your computer. It can actually all be verbal and learning and stuff like that. The tutorial questions will be made available on the weekend before the tutorials start, usually on Sundays. I mean, it just depends on at what point I wish to ruin my weekend by working, because that always happens. But some point on the weekend I will release tutorial information so the students have it and you have it at least before the Monday tutorials. So they're in a system called Blackboard Collaborate. As I was saying before, Blackboard Collaborate is an educational video conferencing system. So honestly, not that much different from stuff like Zoom and Microsoft Teams and Discord video chat, if you've been in any of those. No, people are talking about units of credit and stuff like that. I'm not going to go into that. I've got actual content to talk about here. So I think Tom's saying we might want to do something where we talk about how Blackboard Collaborate is working, but we'll get into that. Tutorials are very good for talking to your tutor because you can't really talk to me that easily in the lecture because there's too many people and I've got planned content that I have to go through. But in the tutorial, there's always time. And this 1 hour here, ooh, hang on, shrink my face again. The 1 hour is a bit more fluid than it used to be. So if we were in person teaching, we would have one room for 1 hour and then a lab for 2 hours. But because we're all in one Blackboard Collaborate session, tutorials may extend longer than an hour depending on how your tutor decides to teach them. I give them full reign over these things. They know what they're doing. The lab sessions follow immediately from the tutorial. So basically you've got a 3-hour block with your tutors to learn from them. But it sort of flicks between these two forms. One is this interactive thing where you're talking to each other about things and you're not necessarily writing any code. The second half of it is a lab session where you stay in the same Blackboard Collaborate session, but this is a time for you to write code and for you to talk to your tutor specifically about the code that you're writing. Tutors, I should say. Everyone has 2 tutors in their class, so there's one person who's delivering the content and the other person who's there to assist by talking to students. So there will be a lot of practical coding happening in the lab sessions. Some of it might be broken up into pairs. Some of it might be broken up into small groups. In general, when we're working on lab content, we're super open about working with other people. So we really actually want you to bounce ideas off each other. We want you to solve problems with other people. We want you to have a chance to learn from other students around you or solve problems together with other students rather than having to just kind of hit a brick wall on your own. In the lab content, we've got plenty of other brick walls for you anyway. We've got an exam at the end of the course, right? So we put a massive brick wall at the end, and so we want you to get a chance to learn about coding in a more collaborative environment in the lead up to that. The lab's also a really, really good time to have one-on-one conversations with your tutors. So when you're having trouble with particular parts of the content, or whether there's something in the lectures you didn't fully understand, the lab has, let's say, 25 people in it. I think the maximum is 26. But you never know. Not everyone's always going to be able to be there every time. So I'm saying, say, 20 to 25 people. Which means in 2 hours with 20 to 25 people, there's enough time to actually have a conversation with your tutor. So you could try to make an effort every time that you're in a lab to ask your tutor or either of your tutors. You can go up to them and say, well, you can't really go up to them, but you can at least message them and say, hey, can we have a chat? You can spend 5 minutes saying, okay, this is where I'm up to. Is this okay at the moment? Can you look at my code? That kind of thing. And so this is where we can get a lot of help for things that you can't necessarily get in lectures, where I just deliver content and I don't really get to check whether you're on top of it or not. So the lab is a good time for you to see whether you fully understand things and really get a one-on-one to talk about it. The lab exercises that you hand in will be marked, so they'll be worth 10% of your final mark. That's kind of like a participation mark. It's not a participation mark because it's actual work you can do, and you can do it outside of lab hours. So these are due at the end of the week. They're not due at the end of the lab session itself. So you don't have to just smash out all this code in 2 hours. If you can't finish some of it, you're not sure about it, you want to go back and view the lectures again or something, you can do that later in the week and then finish it. So these will be due, as far as I remember, 5 p.m. Sunday. I think we made a mistake in the first one and made it due at 8 p.m. and then I changed it partway through yesterday to be due at 5 p.m. So we'll be pretty loose with the due date on the first one. Actually, no, the first one's not marked, so it doesn't matter. Now that I remember it, the first one doesn't count for marks because the first one's introductory and just getting you kind of into the swing of things. There are also challenge exercises every week. So the challenge exercises can earn you bonus marks. Some of the challenge exercises are really weird and really different. Some of them do things that are not even necessarily part of what you need to know in COMP1511. Some of them are just interesting ramifications of what we've taught you in COMP1511. Some of them are for those people who have been programming for years and years and years, and the examples we're giving everyone are things that they've already done in other languages, so they're easy for them to do in C, and so they're just throwing something hard so that you're not bored. Some of them are super hard as well, so they're very interesting. My advice about the challenge exercises is they are never worth the amount of marks that we give them. They're worth it to you as something that you are interested in or not. But if you're here to get marks, they're not necessary. In fact, you could never look at any of the challenge exercises and still get 100% in the labs by the end. So this works both ways. This also means that for any of you who see the challenge exercises and think, what is going on there? If you think that, my suggestion would be to ignore them, or at least just sort of skim them and go, that's something to think about later. The challenge is there if you want to push further, but if you've never done programming before and the course is pushing you enough as it is, I don't want people to take on extra pressure from stuff like challenges. That's why they're in a separate section. In general, if we overburden you while you're trying to learn, then you will learn less than if we had those things sort of not exist at all. So we kind of want to be careful with that. But again, you're in control of your own education, so it's up to you to gauge exactly how much of everything that you're going to consume. Okay, weekly programming tests. These aren't going to start until week 3. But what we're going to do is have these tests that will run every week. Shrey's like, Mark will cover weekly tests soon in the slides. Bang on. Shrey's one of the tutors as well. He's a new tutor for this term, so I haven't actually given him moderator status over YouTube. Remind me to do that later, Shrey. So, the weekly tests are... The way I like to think of these is these are practice for something like an exam, although our exam's different this term from a really full-on exam, but you could consider the weekly programming tests to be quite similar to the kind of thing that you're going to get thrown into if you're doing a job interview for a programming job. So, what we do is, the weekly test you can run for 1 hour. In that 1 hour, you get 3 questions to answer. When you're doing that, these are done under your own exam conditions, so we're not going to be looking over your shoulder and making sure that you're doing these without looking stuff up or anything like that. But to do them without looking up resources is the way that we think they should be done, because they're really good practice if you do that. So if you turn off your internet connection, you're going to need your internet connection. But if you don't look up anything and you just try to answer the questions from the knowledge that you have in 1 hour, the weekly tests will give you a really good indication of how you're tracking. So at the end of the hour, you can say, oh, okay, I answered 1.5 of these questions. So the first question, I'm pretty sure I got correct. The second question, I'm not as sure about, but I think I got most of it working. Then you can say, all right, I'm reasonably on top of this content, but some of this stuff is stuff that I think I might need to look up again later. If you get all 3 questions correct, you'll be like, okay, these particular topics, I'm going to say, I'm pretty happy with these. Later on, when I'm doing my revision before the exam and stuff, I don't need to spend as much time on this because I think I've got this one, you know. So the weekly tests are a way for you to measure yourself how well you're going. When the 1 hour is over, so the weekly test itself has this little timer on the website. When the 1 hour is over, it'll tell you that the hour is over. You don't have to stop working at the end of the hour, but at the end of the hour is a really good time to look at what you've done so far and measure how far you think you've gone. the rest of the time after that, if you want to, if you're chasing the 5% of the course, people do that anyway, that's fine, you can if you want to. You can chase these tiny marks that I've only put in there just to make sure people do things. If you want to max out your 5%, which is never going to count for anything and will be at most a rounding error to your entire WAM, but if you want it, some people like to chase every single last mark, you can then continue on the weekly test and you can go and look stuff up and things like that. So you can try to max that out and get all the questions correct if you really want to. The only thing about the weekly tests is everyone's going to do this 1 hour at a different time during the week. So these are going to go Thursday to Thursday. So I stagger the weekly deadline so it's not due at the same time as the lab. So these run Thursday to Thursday. And the only thing I ask is please don't discuss the weekly tests publicly, as in on, I know there's a Facebook chat for this via CSE Slack and stuff like that. And I know that we've got our forums as well. Please don't discuss any of this stuff in public posts anywhere until after they're due. So it's basically like we're all watching a TV show that comes out every week, but we don't really want to discuss it by spoiling it for other people. So we don't want to give away the solution to other people, because that gives up, that kind of ruins their chance to figure out, without knowing anything about it, where they sit in the course. So it's the same thing I was saying before about like don't disrupt other people's education. Same thing, don't give spoilers to things that people haven't seen yet. So we won't discuss any weekly test publicly until the Thursday after it's due. So it'll be due on the Thursday, and then after that Thursday we can talk about it, but until then we can't. It's like locking down, I don't know if people were watching The Mandalorian like late last year when it came out, because I had some friends that were watching it like the second it came out and then posting on Facebook about it, and I was just like, can you not? You know? So this is the same situation. So we want to give everyone a chance to watch it without spoilers. And by watch it, I mean like do the questions. Okay. The assignments. The assignments are bigger things. Isaac's asking, can we obtain the 5% the weekly test even after the 1 hour is up? Yes, you can. So the thing doesn't lock you out at the end of the hour. It just tells you when the hour is up. So the thing that I would like people to do is when the hour's up, look at how much you've done and then get an understanding for where you sit in the course. And then, I was just going to go back to the slide while I'm talking about it, then you know what you maybe want to ask your tutor about. So the next week you can go in and say, hey, I couldn't finish this question in the weekly test. Is there something I'm missing? And your tutor can go, hey, here's a concept that you might want to go look up. You know, so at the end of the hour you can assess where you're at, but I'm not saying that you're just locked out of finishing them later. You can continue them afterwards. The other thing that's interesting about the weekly tests, you'll find this out as you go through them. First question's reasonably easy, second question's medium hard, third question's super hard. So do them in order, and then you'll find that a lot of the third questions you can't necessarily get going in the hour, and that's fine. So it's kind of like, if you can do the first question, then you're okay. If you can do the second question, then you're going to get a higher mark. You're looking pretty good in that. If you can do the third question, then you're someone who's like looking at a distinction or a high distinction or something like that, the higher grade marks. I haven't really talked about the grading of marks, like, you know, 50 is a pass. This is for those of you who haven't necessarily done university before. You get a mark out of 100. In high school, you try to get 100 in everything, and that's like, okay, you just do all the work. In university, that's basically impossible. So you get a situation where passing's good. Passing means you have shown competency and your capability to do something, which means we think you're professionally capable of doing it in the future. Credit means you put more work in and you learned a bit more than you needed to, so you're being credited for that. That's a mark of 65. A mark of 75 is a distinction. A distinction means you've proven your capability to go beyond and you've learnt content that was not the core for what we expected for the course, but other stuff that we put in the course to see how far you could push yourself. And a high distinction is a choice. A high distinction is a choice between your time and your life and your other subjects versus this subject. So if you decide that you're going to risk how well you do in other subjects, and you don't like seeing your friends, then you can go for a high distinction. that's that's the way it is. I always like kind of joke about that, right? Because I don't know, I can't remember how many high distinctions I actually even got in my time at university, but it wasn't a massive percentage of my courses. It wasn't that many of them. So it's the kind of thing that some people try to aim for all the time. Some people aim for a lot at the beginning of their degree, and they realize that like that's not a good way to live. And they decide, okay, I'm going to go for some high distinctions, and other times I'm just going to like take it easy and actually like try to control what I do. I talk about this in greater detail later on in the course when I'm talking about surviving things, rather than like, you know, just aiming for success all the time, which is like an interesting way to think sometimes, I think. Anyway, let us continue. So, okay, I'm going to ignore chat because there's actually a lot of content there, but I think there's a whole lot of good answers happening to questions there. So I'm going to ignore it for now, and I'll talk about it with the tutors in the break. Okay, so assignments, bigger projects. All of your labs are going to be like small self-contained questions that I consider to be quite possible to complete within like, you know, an hour or two, because they're designed to be completed, at least part of them to be completed in a 2-hour session. Assignments are larger scale projects that I would consider closer to real programs. I put that in quotes because, like, what is a real program? All programs are real. Or none are. They're all virtual. Okay, I'm going to stop before I go on there. But these will be your first kind of more serious projects, and they will give you a few weeks. Each one has nearly exactly 3 weeks worth of work in it. Not 3 weeks worth of work, but we're going to give you 3 weeks worth of time in them, and they're going to give you a chance to take some of the stuff we've been teaching and apply it. And then if you want to push further, we have the assignments are separated into stages. And so there's the early stages, which we consider a pass, later stages for credit distinction, high distinction kind of thing. So you choose how far you want to go into the assignment. They will give you a chance to put stuff into effect, but not just put our teaching into effect, but put it together into something that becomes this whole working program. So the further you get into the assignment, the more stuff you can do. And so it's a lot of fun because you can piece together a reasonably large project in 3 weeks. For most of you here, these will be the biggest programs that you've ever written. I always like to joke about it. They'll be the biggest programs you've ever written, and then afterwards they'll be the smallest programs you ever wrote. So it's always funny. They're part of a progression curve, which is why the second one's worth a lot more than the first one, because the first one is it can still be quite daunting as a first program. But in a couple of years, you could look back and go, I could write that thing in half an hour. Maybe, depending if you stay in computing or not, or you go off and do other things. So the first one will be released at the end of week 3 and will be due at the end of week 6. The second one will be released at the end of week 7. Week 6 or week 7? I think it will be released at the end of week 7 and be due at the end of week 10. They're both in 3-week blocks. These are worth a big chunk of your final mark. So total for these is worth 40% of your final mark. So that's quite important. There are also help sessions. Help sessions are entirely optional. They're up to you whether you go to them or not. The way that help sessions work is everyone joins a Blackboard Collaborate session and they log on to this little system. The system is basically it's like a queue. You take a number, you get in a queue, and there are tutors who work in the help sessions, and the tutors are going to meet everyone in the help session based on the order that they joined the queue in the help session. And then you can have a one-on-one conversation with someone. So your normal labs are actually pretty good for this as well, because you can talk to your tutor there. But if you're feeling like you need more help outside of the labs, feel free to go to the help session, because you can go to the help session, and one of the best things that people use the help sessions for is they go there with some of their code. So it's like, I was writing this in the lab, it doesn't work, and I'm not sure why. and you can get someone to actually look at your code, and they'll be able to say to you, have you thought about this or this or this kind of thing? And you just go, no, I haven't thought of any of those things. And then when you do, you can go through and they will show you how you can fix your own code. So help sessions are pretty handy like that when you're having trouble and you're not sure where to turn. So you hit this kind of mental block and you're like, I don't know how to fix what's going on here, because, you know, learning another language, learning a programming language is not a simple thing to do, which is why this is a university course, right? It's not a simple thing to do. It's something that takes a lot of time and practice, and so having a bit of help while you're going through that is handy. There are no help sessions in week 1. The help sessions are in the process of being scheduled, and they'll appear on the course website in a section there with a schedule once they get started up. One thing that I think we're going to do with the help sessions, this may not be fully relevant for everyone's here right now. I know that we have some international students now who were not able to travel to Australia, so we're thinking we might be able to put some help sessions on in some really weird hours. So if you're an Australian student, you look at that help session and say, why is that even there? But we might be running some help sessions that are in hours that people on, say, European or US time zones will be able to reach them without having to be awake at some ungodly hour that they would normally have to be to take part in the content. So we don't really want to unduly disadvantage people who can never actually turn up to their tutorials and labs because they happen at 2 a.m. or something odd like that. So we'll have help sessions at other times so those people can actually get some face-to-face contact. Face-to-face. I mean, it's not physically face-to-face, but it's still digitally face-to-face, so hopefully that's enough. They're going to be, they're going to be released hopefully later this week. Okay, live streaming. Very awkward, because this is not technically a live stream, this is a lecture. Live streams are at other times. So basically, if I announce a stream that is not in the official time, so 9 a.m. Tuesday, 4 p.m. Thursday, official lecture time. If I announce streams that are happening outside of those times, those are optional streams. You don't have to go to those, but they might be handy. One of the things I'm going to use the live streams for the most is here is the assignment and here's how to approach the assignment. Sorry, I've gone way over time for the first hour. This usually happens in this lecture anyway because I try to cover the whole course in the first hour, while I try to also talk to you about things in the beginning as well. Okay, so these are extra streams where sometimes I will not have structured content for these. So sometimes I'll go into a live stream and I'll say, okay, I'm here, I'm available to talk to, and I will actually participate a lot in the chat. And I'll say, okay, what questions do people have? I'll work on things and I'll give you some answers to things, or I'll be like, I won't always give you the answers, by the way. Usually I would give you a way to find the answer for yourself. But someone can say, look, I didn't understand this particular concept that you were talking about in lectures. And I say, okay, let me go over it again, and I'll try to teach it in a different way than I taught it in lectures. So maybe it will have some more understanding. Or it's like, some of these are, I just didn't finish the content in the lecture time, and so here I want to go do it again. So these kinds of things. One of the big things, I will always try to schedule these in the weeks that the assignments are released. So I'll release the assignment spec, which will be a document saying, okay, this is what you're supposed to do, and then I will wait a few days, give people a chance to read it, and then I'll put up a stream later on that week. Probably, considering we're Tuesdays, Thursdays for lectures, the streams are most likely going to be Friday afternoons. There's one this Friday, actually. It's not a live stream, but there's actually an activity for COMP1511 students this Friday afternoon. We'll talk about that in a sec. Yeah, so I will do those live streams a lot to talk about the specifics of the assignment, because the assignment's always different, right? So if you found news of assignments from previous terms, it's highly unlikely that that's going to be that relevant. So actually you can see live streams about previous terms, and so they're going to have, the assignments are on different themes than we do this term. So what I'll do is I'll do that stream and be like, okay, this term this assignment is on this kind of thing, and so this is the way we're going to do it. There's an exam as well. The final exam is our way of just checking that you're okay with everything that we've taught over the term. Usually we would do this on our labs. Obviously we are not going to gather together this term, so none of our classes, well, I don't know if none, but I'm reasonably certain, like 99% certain, that our classes are not going to go face-to-face this term. I think that the easing of restrictions and the maintaining of social distancing is going to continue all the way through this term minimum. So I'm expecting that we're definitely not going to be having an exam in person, so we're already planned to have this exam as a take-home exam that goes over a 24-hour period. So the only reason the take-home exam is 24 hours is because we have students in different time zones. We do not in any way expect people to be spending 24 hours on the exam. Please don't. You will hurt yourself. It is not necessary. You should be able to exhaust your knowledge of everything and answer every question to the best of your ability in about 3 to 5 hours. We actually designed the exam around a 3-hour time period, although it's designed to like kind of burn you out in 3 hours. But if you spent like 5 hours on it, that would be enough. Don't spend 5 hours in a row on anything ever, says the person who regularly spends 5 hours gaming in a row. Anyway, let's not talk about that. We expect about that amount of work, and then you will run out of the chance to get any more marks in a sense. So what's going to be in the exam? I have a whole lecture dedicated to what's going to be in the exam, so today I'm just going to gloss over it, and we'll talk about it more later. Also, it doesn't matter if I tell you what's in the exam now. I haven't taught you anything yet, so it has no context. But basically, we will give you a whole series of problems, and you will have to solve them using C. We will also ask you a bunch of questions to see how well you understand C and understand some of the concepts around programming. They will be in a really, really similar format to the lab and weekly test questions. The majority of the weekly test questions are actually questions that used to be in the exam. So that's another reason why the weekly tests are good practice, because they're practice for the exam. We also have these things in the exam that we call competency hurdles. So these hurdles are our way of saying, if you can't do certain specific things, these are the baseline things that we consider necessary for you to understand to be able to continue on to things like further courses, or for us to be able to sign off and say, look, this person knows what they're doing. Again, it's not really relevant for me to talk about exactly what those hurdles are, because I haven't taught you the content yet. So I can say there's a question using arrays and there's a question using linked lists. But since I haven't taught you what an array or a linked list is, there's no way for you to prepare for that yet. So when I introduce these concepts, then you should have a decent understanding. And I'm going to talk about the exam again later. So I'm going to say, let's put the exam aside and we'll talk about it in the future. But at least you know the format. We'll give you 24 hours. We expect you only spend sort of 3 to 5 hours working on it in any particular, in that particular amount of time. Okay, so if we add everything up, we have 10% for the labs, 5% for the weekly tests, 40% split up into the 2 assignments, and then 45% for the exam. To get a pass in the course, you need 50 or more out of 100 overall. This, as a percentage, adds up to 100. And then the 2 things that I was saying, so I've said it specifically here, solve problems using arrays and linked lists in the final exam. So this is you want to play the numbers game, here are the numbers. Personally, I hate the numbers game. I think that the whole reason that people are at university is to learn things that are going to be relevant for a career path they're looking at, or relevant for how they want to approach something in the future. So getting 100% in something but deriving no genuine understanding from it, I mean, kind of impossible, but, you know, getting all the marks. Oh, you can do it if you cheat, yeah. Like, you could get all the marks in something, but it's not worth anything to you. So the marks are a rough guideline on how much work I think people ought to be putting into things, but I don't think they're something that you should, aim your entire life's effort at. So the assignments is because of the amount of effort that goes in. The exam is because it covers the entire course, roughly like that. And the labs or weekly tests are just like an ongoing thing to try to encourage you to keep practicing as you go through the term. Okay, I should break soon, but I should talk about this before we go. Okay, so special consideration is dealing with any issues that make it difficult for you to study. So anything that's causing you to not be able to do the course the way that it should be done. So pre-existing conditions, any illnesses or anything like that, please let us know. So UNSW has a way of doing special consideration claims. They will go through the student nucleus, I think, and then they will contact us and they will say, okay, we've verified this person's claim, they have these kinds of adjustments. And I think that's a nice way of doing it, because that way I don't actually know anything about why someone has a claim. I get told that the claim has been verified and that they have special consideration, which is really good because it removes any kind of bias I could have. So if I have someone who has a particular condition and I know about it, then maybe I'm going to judge them differently or something like that, and it's better that I don't know about these things. It's a lot fairer. There is a second exam called a supplementary exam if people can't take the main exam, and that will be happening in September. It hasn't been scheduled, but the rough week of it will be this week of the 7th of September. If you have any issues or need for help or anything like that, generally your tutor is the first port of call, but then you can also email us at the CS1511 email address. If it's something that requires special consideration, you can talk to the student office as well. They will often liaise with us with it and make sure that we're giving you the right adjustments as well. Course textbook. So I have to admit that I do not use the course textbook. All of the resources I have for the course are stuff that I've either written personally or other people have written who have worked on the course. So a lot of the tutors have written questions for me here and there that I use. You can use this book if you want to. It might be interesting. So everyone learns in a different way, right? Some people are getting everything they need out of this course from me right now, because you learn by listening. Some people are getting very little from me right now because you learn by doing, and so you're waiting for your tutorial or lab for you to really learn. I'm actually like that myself. It's ironic because I run the lectures now. But some people learn by doing a lot of reading and exercises and things, and this book might be really good for that. Okay. Code of conduct, I think this is quite important as well. As I said before, university will give everyone a chance to learn regardless of your background or of your situation, which means if your situation is causing problems, we do have special consideration to help. Especially in this time of lockdown, we can't provide resources for everyone. So if your internet connection is not perfect, which I'm sure heaps of people aren't perfect, get in contact with us. There's going to be some way that we can help you. We can at least try to help you in some way. The one rule is you do not hinder anyone else's learning, and this is where the code of conduct comes in. If you want more rules so that you can follow the one rule, the code of conduct, which I should have linked on this slide, but I haven't, there is actually a student code of conduct that you can follow. So anything connected to COMP1511, including social media where people are discussing anything on COMP1511, will follow respectful behavior. So we will not discriminate against anyone in any way. There will be no harassment of people, bullying, no aggression, or any kind of special asexual harassment or anything like that. So that's the kind of thing that I say definitely will hinder someone else's learning, and I'm not really okay with that. And I'm sure that a lot of people are not okay with that as well. So I think this is the kind of thing where we really want to kind of support each other, especially in this time where we don't even get to meet people in person. We don't. It's harder to make friends at uni at the moment, and that really sucks. Um, so what we want to do is just try to make sure that what we're doing is looking out for all those people who are kind of alone studying online. You know, people who we might have been friends with if we'd had a chance to sort of strike up a conversation. So, especially now, but in general all the time, is we're going to have a lot of respect for each other, and we're just going to try to be nice to each other, so that when we come out of this lockdown thing, maybe we'll be able to look up those people who we're in tutes with and go, hey, you're a real person, not just like a face on the other side of the screen and stuff, you know? And yeah, just be excellent to each other. We're also going to respect the privacy of other people, so people might, you know, when you're working with someone in the lab, you might have access to things like being able to see via their camera what's in their room and stuff like that. So for me, I'm happy to talk about what's in my shelf because I did set up this camera and I did check what was behind me. I think I did, I can't remember, to make sure that there's nothing in there that's going to be like, you know, privately condemning to me or anything like that. But we want to respect that other people may let you see into their homes because we're doing this online, and we want to respect that, you know, and so we're not going to go around and tell other people about things. Okay. I'm going to talk about this afterwards because I've hit 10:30 and this is a little bit longer than I wanted to talk in one go. So I'm going to talk about plagiarism after the break. So in the break, I'm just going to take, I don't know, like 3-4 minutes. So I'm going to take a huge amount of time here. I thought I'd leave you with this little link. This doesn't work as well as it used to because it's in Flash and not everyone's browsers really support Flash anymore. But here's this lovely little game called Lightbot that was used to teach people how to program for the first time. And so without a full-on programming language, this teaches a lot of the core concepts of how programming works. So you basically give a series of instructions to this little robot that walks around this space and has to turn on all of the lights wherever it hits a colored square. It's quite interesting, so check it out. You can actually download it for your phone as well. At least I think it still runs on phone. I haven't tried downloading it for a while. So, let me... I'm going to go on break for the stream, probably only about 3 or 4 minutes break. Tom, I don't think that we are going to get a chance to necessarily do stuff with Blackboard Collaborate in today's lecture. Maybe on Thursday, because we're already over time, and I'm going to have to squeeze in the second half of this lecture. Alright, I'll go on break now. We'll be back around 10:35. See you soon. I'll switch this. Alright, alright. I'm back early. Just give me a sec. Yes? You're gonna say hi to everyone. Yes! Here's Chicken. Everyone was asking to see her, so I went and found out where she was. And she can say hello for a little bit. And then we'll get back to the lecture. I don't know, maybe she'll just sit in my lap for the rest of the lecture. We'll see how we go. This is such a cheap trick. I would like to be popular with my students. Here is an animal. Okay. No, that's right. She's done. She's leaving the room already. But at least she came in for a little bit to say hi. Okay, let's go back to where I was a second ago. We were talking about plagiarism. So I'm going from cute cat to the roughest thing that I want to talk about today. So plagiarism is the idea that we may present someone else's work as if it was our own. We may do this inadvertently. We may end up doing this by accident, by collaborating with other people and things like that. But this is something that we do need to talk about, because there's always a few people who end up doing something like this. In the course outline, we've got specific details of what's going to happen if we find a reason to look into the code that you're writing. I just want to talk about the cause for this most of the time. So a lot of the time, for a lot of students, the reason why you might end up copying someone else's code is you kind of get desperate. You hit a point where you know that you don't quite understand what's going on, and you think that you really need this to get the marks that you want to get. So I say, for anyone who is in that situation, usually this is going to be like the day before the due date or something like that, or even the day after the due date, because you can still hand in stuff a little bit late. Please get in contact with us. Get in contact with your tutor, or you could email me on the CS1511, but I think your tutors may be a good port of call. This is always a standing offer from me in this course, is that if you're desperate and you need help, then we'll ease off. So if you hit a point, you could literally do this. You can literally email me and say, I think I'm about to cheat. I'm not happy with how things are going. I don't understand what's happening. What can I do? And we'll try to give you an extension, and we'll try to give you some one-on-one time with a tutor. We'll organize someone to meet you at a help session and see if we can get you over the line. We much prefer people to get a basic enough understanding of things to pass something. We much prefer that than to someone just copy code from someone else and then we have to have a chat with them after the term and give them 0 for things, and just like, or worse, you know, like put you on a record which may be might be a problem for the rest of your degree and things like that, right? So anything that we consider an individual assessment, which is assignments, weekly tests, and the exam, are things that we expect you to be doing on your own. I think one of the things about this really is that even if you do cheat and get away with it, it doesn't really do anything for you. Like, yeah, you'll get through this course, but like, if you didn't do the work in this course and you go on to other courses that are harder than it, then you're not going to know what you're supposed to know when you get there. So it's actually just going to be worse for you in the long run. And if you do manage to sort of kind of like find your way all the way through your degree to the end, like paying other people to do your assignments for you and stuff like that, all you've done then is get a piece of paper at the end that says Bachelor of something or other that's completely worthless because you didn't learn anything on your way through. The value of being at university is learning things so that you can have more capabilities than you used to have before you got here. If you go all the way through without learning anything, then all you've done is spend a whole lot of money. And then when you actually go and try to get work and things like that, no one's going to hire you because they're going to see quite easily that you don't understand anything. So that's, I mean, there's not many people who are going to do that, but there are some people who cheat intentionally, and I'm just saying, it's like, what's the point? If I was going to pay to go to university and then pay someone else to do my assignments for me, why don't I just like unenroll and not pay anyone anything, and then I'll have more money in the long term? And so what I'm saying is, if you do feel the need to cheat, let us know. We'll help you, because this isn't about, like, I really don't enjoy dealing with plagiarism, because I don't enjoy having to punish people who just needed help, right? So if you need help, please reach out, ask us for it, go to help sessions, talk to your tutor, ask your tutor for time in the lab and stuff like that. That's always going to be a better way around things than asking your friend for a copy of their assignment, because that tends to bring both people down. Whether or not it's your assignment that you lent to someone else or you've taken it from someone else, you're both going to get caught up in this kind of thing. And again, the golden rule, don't disrupt other people's education. If you give someone the answers to questions, then you're disrupting their education, because you're not giving them a chance to work through these questions to the point where they understand them. Because I don't really care whether you finish your assignments or not. I care whether you are working on them, because the time spent working on them is learning how to do things. Okay, a lot of detail here on the difference between working with people and actually cheating on things. So you can talk about what things mean. You can talk about the overall concepts. The internet has heaps of information about these things. But once you start talking about the actual assignment, so you actually talk about the way to solve a particular problem in the assignment, that's where this becomes collaboration. It becomes an issue. Well, it becomes plagiarism, because it becomes an issue that you're not letting someone else do the work themselves. So you want to make sure that, like, one of the easiest things is never talk about the assignment while it's happening. You can talk about the ideas that need to be learnt to go into the assignment, but talking about how to solve specific parts of the assignment is generally going to take away other people's chance to learn how to do those things. So that's the level that I want us to be at, if we can. And so there's a few rules here. Don't use other people's code. Don't talk about how to solve the problem. So don't ask someone else to solve the problems for you, because someone else could say, oh, just do this, 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 and this, and then all you're going to be doing is translating their ideas into code, and then you end up with a situation where you didn't actually learn how to solve the problem, so you didn't go through the steps to learn how to solve it, so you've missed out on some of the learning. So just be careful with that. And also, if someone asks you for code or asks you to solve problems for them, please don't, because you're not helping them. You may think you're helping them, but you're actually not helping them, because you're taking away the learning that they would have had by working through the assignment. So kind of the best thing that's going to happen to anyone who cheats on things is that they just get 0 for that assignment. That's like the best case. Worst case is much worse than that. So for example, if you pay someone else to do your assignment for you or something like that, or you get an ex-student to work on an assignment for you, there's a chance that you may actually even just be completely asked to leave UNSW. Unlikely if it's your first offense or anything like that, but the details are details. We'll get into that. And again, what I was saying is that if you're cheating, the thing you lose out on is the fact that you paid all this money and you didn't get anything out of it. You know, so that's what I want to talk about for that, is cheating only reduces the amount you learn, and if you're not here to learn, then I think that's a much bigger question that you need to ask yourself about what you want to do with your life if you didn't come to university to pick up something, some skills, or something important that you want to use later. Alright. I am so overtime at the moment. I keep forgetting that when I do lectures in live streams, I don't think I go at the same pace that I go in person. I think there's way more adrenaline when I'm in a room with a few hundred people, and so I push a lot faster. So I'm sitting here in my little home office space, and there's it's much easier for me to not drive the content. Okay, so I want to talk about what it means to do something like COMP1511, but this is just general advice for learning. And so people often ask, okay, how can I do well in COMP1511? And the answer is always the same thing. The more time you spend learning something, the better you get at it. That doesn't mean you just need to keep doing the same thing over and over and over again. If you want to learn a physical skill, then yes, do that. It's very good for muscle memory. But for computing, it's about spending the time you need to pick up the concepts you need. And this might mean looking at things from a lot of different perspectives, looking at how other people approach things, all that kind of stuff. But what we've done is we've set up the course so it's structured in a way that we deliver ideas to you in lectures, then we work on them in tutorials, we solidify them in the labs, and then we find out how well you retained them a week later in the weekly tests. There's a reason why the weekly tests don't start until week 3, because it's kind of like lecture week 1, tutorial lab week 2, weekly test week 3. So it kind of works in this kind of thing where each topic has 3 weeks worth of coverage, and there's this kind of sliding window of 3 weeks that goes through the term. So what I'm also saying is there's no real shortcut to being good at programming. Good at programming is like a real kind of like, what does that even mean? Getting to the point where you're happy with what you've done. So if you follow everything that we're teaching, we have structured this in such a way that you'll get a lot out of it if you can go through it all. And I do understand that people have a lot of demands on their time. I don't know if people are taking extra subjects this term because they had to pull out a subject last term for various reasons. I think last term was more disrupted than this term is. At least this term we're going into it online, knowing that we're going online. One thing I always try to tell students is don't focus on how good you are or what you do and don't know. Especially don't focus on how good you are at programming versus the people around you, because if you want to, you can always look around and find someone better than you at something. And if you really want to do that and you put a lot of effort into finding someone better than you at something all the time, you can just demoralize yourself. Compare yourself against yourself previously. If you're getting better at what you're doing and you're learning more than what you knew before, then that's good. That's you progressing. That's important. If you keep chasing someone else, then you kind of have nowhere to go, because if they stop getting better, then you'll stop getting better. If they keep getting better at the same rate as you're going to feel like you're behind all the time. So try not to compare against other people. I know this is a really hard thing to say, because I can just say it and just don't do that, but you're going to do it anyway. Because that's psychology. That's just one of those things that happens to people. But if you can, try. Because this is the only way we're going to get to the point where we have a good mindset about things, is for us to try to work on it. So focus on what you thought you were capable of before and what you are capable of after you practice things. And then you may find that putting some time in and practicing things gets you better at things. So, I want you to unlearn what you have learnt. What I mean by this is that we are approaching something new here. I mean, for some people it's going to be new, for some people it's going to be less new. What I want us to do at all times when we're learning is try to approach things with as open a mind as possible. So we want to approach all new content we're learning without thinking about what we knew about it beforehand or what we knew beforehand at all, and just saying, okay, here's a concept that I've never seen before, or even here's a concept that I've seen some parts of before, and I'm going to take this as something brand new, and I'm going to work on it and see where I'm going. That's where I just wanted to, I mean, I could talk about this for the next 2 or 3 hours, but I'm not going to, because I should actually finish this stream on time. Okay, so if you want more info about the course, there's the course webpage, course forum, the YouTube streams can be replayed, one-on-one help can be got via the help sessions, and also talking to your tutor. If you have any bigger issues and stuff, our email address is here, but also general student support at the Nucleus. CSE, the School of Computer Science and Engineering, has a little help desk webpage. There is some information there as well. Hopefully you can get all the information you need from all of these different sources, or if nothing else, some of these sources will be able to give you information from other places. Speaking of email addresses, please make sure your UNSW email address is set up and you're receiving things. All official course notices are going to go out on that. The official course notices are also going to appear on the course website, the WebCMS website, in the notices section on the homepage, but there will be other things emailed out to you. So we will email out regular things reminding people of when things are due. Everyone got one of those last week when we left an exercise with a different due date than what it was supposed to have. We apologize for that. I got a lot of panicked emails going, what do you mean? The course hasn't started. Why is something due? And I was like, sorry. Yeah, but we're going to use those properly during term to remind everyone that things are due, and so that you can catch up on things if you need to, or it's like, oh, there was that lab exercise I didn't finish. I can submit that now before it's due. So we'll generally remind people just before the due date. It's like, are you sure? Here are some things you may or may not have finished. If you want to contact us, just make sure, try to use your UNSW email address, so then we know it's actually official communication, because it's likelihood if it comes from a random address we won't do anything with it. Include your ZID as well anytime that you're going to contact us on the course account, so that we know who we're talking to. Okay. I have 8 minutes left, and I'm wondering on how deep I want to go into these next few slides. I think I'm already going to have to do a live stream to catch up with this stuff. I don't know whether I should go overtime or not, because some people are going to want to go to their tutorial. I know that we'll have some people in the next tutorial, but I might just keep going anyway. Okay, so I want to talk about what a computer is. Here's like the actual kind of first bit of learning content. I'm definitely not going to finish this in the time I have left today, so I will probably record a video for later and put it up online. But anyway, so a tool is a computer. A tool is a computer. A computer is a tool. So a computer is a machine that can do complicated things. I could say a hammer is a tool as well, and a hammer has a purpose. It has the ability to, attach pieces of wood to each other by driving a nail through them, and that's really cool. That's really handy. It's a miracle of human ingenuity that we can create things like hammers that allow us to manipulate the world in an interesting way. The computer is the greatest tool that we as a species has ever invented, because it was the first tool we ever created that was completely reconfigurable for many different things. And it was the first time we created a tool that could nearly mimic our own thinking. I mean, in many things, it outstrips our capability to think about things in massive ways. Just doing simple maths, the computer is always more accurate and faster than a human. It has the amount of memory the amount of things that it can remember in perfect detail is way beyond what we could do. So it's very interesting because of that. The key things theoretically that make a computer work is a thinking bit and a remembering bit. And so I'm going to keep this in the simplest terms we think about. The processor is something, and we've probably heard of processors before. Like, you get sold a computer that says it has a certain CPU in it. CPU is a term that means central processing unit. We're going to call that the processor a lot of the time, and it's the thinking bit. It's the bit that says, what do I do next? And I'm going to do something. And then we have memory, which says, okay, let me remember certain things. So it's like, I'm going to remember a series of numbers and I'm going to be able to work on them, or I'm going to store information, like even this set of slides is stored in memory on a computer. So the computer's always going to be separated into these two things, and we're always going to be working on these two things in this way. We're either going to be executing commands using some part of the computer, or we're going to be storing information using the other part of the computer. I'm not going to go too much into the physical detail of these. I wanted to talk a bit about the history of computers, because it's good to spend some time thinking about where this came from, what it is, and also the fact that this is a really, really recent scientific field. So we can track the beginnings. I mean, if we don't want to track the beginnings down to like theoretical maths, so we have thousands and thousands of years if we want to go into math. But if we're talking about computers themselves, there was a person named Charles Babbage who came up with this idea of an analytical engine. It was a mechanical machine that was able to compute numbers. The interesting thing is he came up with the idea and he designed it, but he never actually got it fully built, because the ability for us to machine mechanical parts in that era wasn't quite good enough to get this done. Ada Lovelace is someone who worked with him, and you may have heard her name before if you've studied any of the history of computing. She is the person we credit as being the first person to write a computer program. So she took the idea of the analytical engine and then started writing procedures for it. So started writing sequences of commands that this engine could execute, and in doing so it would actually go through a complex calculation and come up with a solution at the end. And then this was the kind of thing that could take different inputs and give different outputs. And so we usually credit her as the first person to write computer programs. And it's really interesting that the first people who made the computer, well, the analytical engine at least, and the first computer programs never really got to see them working, because they never actually managed to build this thing, and they never actually managed to run any of this code. So you imagine how difficult that would be if I was to teach this entire course and say, none of us are going to use computers. Here's an idea of what a computer is, and now I expect you to write code. So this is what they were working with back in that era. Skipping forward nearly 100 years, over 100 years, to around 1944, this is a person called Alan Turing. Alan Turing worked for the UK in World War II and developed this thing called this concept called the Turing machine. Worked on an actual computer called a Colossus, and this was made to break German codes. So one of the most important things that the British were working on late in the war was how could they keep the naval convoys that were delivering supplies from the USA across to the UK during World War II, how could they keep them safe from the Germans? They couldn't break the German code, because the Germans had this really amazing machine called an Enigma machine, which was able to, they could type in things and it would scramble what they're typing in, and then someone at the other end with another Enigma machine could decipher it. Alan Turing and his team developed a digital computer called Colossus. It's this kind of thing that took like a whole room to run and has less power than this. So we could break World War II with an iPhone nowadays. It would be quite easy, actually, considering the complexity of the machines they had back then. But Alan Turing built the idea of digital computing to a point where where they were capable of breaking these codes, and they were capable of turning the tide of a significant part of World War II. And it's really funny because, like, a lot of people, when they talk about World War II and stuff like that, they talk about someone's like, that movie, The Imitation Game, is a real thing. Yes, The Imitation Game is based on a real thing. they talk about the generals in World War II and like their success and things like that, and it's really kind of hard to decide how much effect Alan Turing actually had on World War II. So people talk about tens of millions of lives in terms of being able to finish the war earlier because the Allies had access to the German codes and had cracked them, and so had access to all this intelligence. For us in computing, one of the most important things that Turing came up with was this idea of a Turing machine, which is the theoretical basis of all our modern computers. So back in the 40s and the 50s, I can't even remember if Alan Turing lived until the 50s, but into the 40s, he developed this concept of, as I was saying before, a processor that executes commands and memory to store information. The computers we're using nowadays, again, swankiness of my smartphone or laptops or anything, even the biggest mainframes and stuff like that, are still theoretically doing exactly the same thing as Alan Turing's Turing machine. They're just doing it faster. So it's really interesting that someone who didn't have access to our modern technology and things like that laid the groundwork for everything that we're doing now. So the core principles and the fundamentals of what we're doing came from his theories at that time. So a lot of people consider him to be the father of modern computing. And I kind of agree with that as well, because we still haven't gone beyond his theories. So there's a lot of stuff that we can do. I'm going to skip over this a little bit, but there's a lot of stuff we can do with computers. So I've got a list of interesting things here where we are now able to use that basic concept of a processor and memory to talk to each other over a network like this. So I'm streaming, I don't know into how many countries at the moment, so I don't know. Hey, if anyone here is not in Sydney, Australia, ping chat now and say hi and tell us where you're from. Because this is one of the miracles of computing, is I'm going out live to all these people. So we're in this pandemic lockdown and we can still teach, which is a really, really wonderful thing, and modern computing has delivered that capability to us. We can do really interesting things like simulate highly complex virtual environments and stuff like that. And I think one of the most interesting things is that all of the stuff that we can do with computers we haven't done yet. There's so much more out there, and some of you might be the people who continue the idea of us making interesting things with computers into the future. Okay. Oh, there's a lot of stuff that I probably should cover. You know what? Oh, there's someone from China. Hello, Claude. Hello, Thomas. There's some people in China and Shanghai. That's really cool. I'm glad you could make it, because when we were in person in first term, we had to actually do a lot of rearranging so that we could get people who are living in China to actually be able to do the course this term. So welcome, and I'm glad that you could make it now, because we misunderstood how COVID-19 was spreading around the world at the beginning of first term, and so we knew that there was a travel ban from China, but that's all we knew. So a lot of our students from China are the ones that lost out getting started in the course in first term. So I hope a lot of you are here now, which is really great. Happy to have you here, and it's really good that you're finally able to get into the course now. David's on the Central Coast. No, seriously, I think that us going online may make your commute a lot easier than it would have been otherwise. Okay, so in CSE we're using Linux. I'm going to go a little over time, but I think I'm just going to cover this stuff quickly. We're going to use VLab as well, which is a way to remotely access our computers. Usually this would be something we'd only use if people needed to do homework and stuff, and we have our computer labs available. But this time it's going to be crucial. So in your tutorials and labs this week, we're going to try to make sure that everyone can connect to CSE's VLab at least, or if not, get some kind of programming environment set up on our computer. It's pretty simple. Our needs are pretty simple. We're going to have a text editor, and we're going to have a compiler to do things. So we're going to be working in the Linux operating system. The reason we use Linux is it's quite a useful operating system industrially. So it's funny that a lot of us won't be using it in our computers because the commercial operating systems are different from Linux, and they don't give the people controlling the operating system as much capability for modifying it. Whereas a lot of companies are going to use different versions of Linux. So it's good to get a handle on it now in case you go into a dev environment later that is going to be using Linux. I've got a really simple diagram here of how it works. We're going to write code. Our code is going to communicate with the operating system. The operating system is a piece of software. It's actually just other programs that other people have written that communicate directly with our computer hardware. So they give us this link in between the two. So all of our people here from China are actually a couple of hours ahead. So you're joining at 7 a.m. That's rough. Thank you for putting that effort in to do that. You can always watch the videos later if you want to, if you need to. Like, I understand that like getting up at 7 a.m. every Tuesday for the next 10 weeks might be a bit much. I don't mind, totally try to. Yeah, so we're going to write code that runs on an operating system. So this is just like, this is a massive oversimplification of the software setup on computers. If you want to, you can go into more depth in this. There are other subjects you can learn about how an operating system works and things like that. So a lot of what we're going to be doing is using a terminal in Linux to access our code and access other things. So I've got some commands here which you're probably going to get to use in your tutorials and labs that allow us to navigate the system. So instead of clicking on things, so for example, I don't know if I'm gonna give away any secrets here. I could navigate my computer by clicking on things like this. So trying to figure out where I can open something that's not going to give away something important. I don't know, I'm just not going to open anything. So you can open files by clicking on them. When we're in Linux in a terminal, we're not necessarily going to be doing that. We're going to be navigating by using commands. We're actually going to be typing text commands in. And the basics of what we're doing is using a text editor called gedit. Gedit helps by highlighting colors for things, and a compiler, and the compiler is another program. We're going to be using this one called DCC. There are other compilers like GCC and Clang. There's names for all these other programs. They're all capable of translating C code into something that the computer can run. So what they will do is they'll take the C code that you've written, translate that into another file, and that file is like any program that you could double click on or something that runs, or any app that you can tap on your phone that runs. The compiler is the thing that creates that from the code that we write. So we're going to use things like VLab to access CSC's editor and compiler. So I've already got that set up on my computer. I'm just going to connect here. Don't worry if you don't fully understand what I'm doing here with VLab. This is something that you're going to go through with your tutors. Hopefully I'm not interrupting too many tutorials right now. So I'm going to log in here, and I'm going to be in a Linux environment that I've already set up. So here's my terminal. If I open up a terminal, I can use some of those commands like ls, directory listing. So a lot of this stuff is in this kind of shorthand, and it's nearly like what I like to call the 1980s programming shorthand, where everything had a minimal number of characters in it. So instead of doing something like listing to get a directory listing, they just go ls. Here's a bunch of directories. I've already set this up. You can run a command like this one called 1511 setup once you get going. Of course, you'll need to actually connect to our VLab first before you can do that. 1511 setup does a whole bunch of things that lets your setup end up looking like mine, and it's set up in an easy way for using things. This one didn't really do much because I've already got my setup. But I can do a directory listing, and I can change directory by doing CD for change directory, again, shorthand. And I can go to the COMP1511 directory. You can see I've actually kept the COMP1511 directories from the past times I've taught this. So this is now my 5th iteration of COMP1511. I taught it 3 times in 2019, and I taught it last term. So we're going again, and I've got this one as the current one. Change directory here, and you can see that this bit here tells me where I am. Most of this stuff you don't need to worry about. This is CSE's way of organizing our directories, but here's my account here, and then COMP1511 directory. If I do an ls there, nothing comes up because it's empty. I haven't actually got anything in here yet. So I can make a directory using make-dir, mkdir, and I'll call it lecture 1. If I do ls again, this shows me what's in here, and I've now just created this directory. So it's a little bit like right-clicking and saying new folder or something like that in a Windows system. So here's my lecture 01. I can go into that directory, navigate into that directory by saying cd into lecture 01. ls shows there's nothing in there for the moment. I'm going to, let's open up gedit and start a really simple program. So here's a demo program that I want to create for everyone, and I'll show you how I might do that. So I'm in this lecture 01 directory, and I'm going to type in gedit, and I'm going to call it hello world.c. The .c, I mean, it's awkward because it's gone over the line. The .c says this is C code that I'm going to write. Gedit is the program that I'm going to use to create it. I'm also going to put an and on the end here. Don't worry too much about the and, you can just use it without fully understanding what it does, but what it's actually going to do is allow this window and my gedit window to both be running at the same time. So I do this, I have now got this directory here. Now I'm going to write the code, actually I'm going to copy the code in. I'm just going to copy paste this. I hope that there aren't any weird invisible Windows characters in there. Probably not. So I've just done Control C and Control V to copy this code in here, and then I just press Control S to save that. Put myself down here so I'm getting in the way less. Okay, so this is a demo program that I wrote last year, and I'm going to break down a little bit about what I'm doing here. So I've actually got slides for all of this, but I probably won't go back and forth to the slides, and I'll just talk about it here. So this bit, these double slashes are what we call comments. And what these do is they allow us to say something in our program that is actually for humans and not for the computer. So it's interesting because I consider that like half of our programming is for the computer and half of our programming is for humans. We actually put a lot of effort into making sure our code is readable. Not only is this important for us, because when we need to reread our code, we need to make sure that we can actually understand it, we can make changes in it, but also if we were to give it to someone else, then they would understand what's going on. So I put this in here, which is just in plain English, saying I made this at this point in time and this is what it was for. This is enough information that someone's going to be able to see this program and not have to decipher it by looking at it, looking at all this weird kind of other language. There's some really plain English that just explains what it is. We can put these comments in the code as well. So here's a comment in code. And if we want to do a large block of comments, we can open the comment with /* and we can */ to close a comment, and we could type in a whole bunch of stuff in here. The importance of having these symbols to work with comments is that comments are not intended for the computer, they're intended for humans. So when the computer reads the code, it will ignore anything that's in comments. So the computer will not read the comments and will not try to execute the comments. It will not treat them like instructions for itself. The next line we have here is #include stdio.h. For the moment, we're going to ignore this. we're going to be putting it in most of our programs, and I'm going to say that what this does is it includes the standard input output. So this allows us to send text to this screen and also read text from that screen, but the details of exactly how we use this we're going to go into later in the course. So for the moment, we're just going to use the line without necessarily knowing how it works. Then we have this section here, which is int main void, open curly brackets, close curly brackets, and in between a bunch of stuff. So int main void is something that we're going to see in all of our programs, and again, it's another thing that I'm going to explain in great detail later. This one will come sooner than the include, in a couple of weeks. But we're going to call this the main function. So the main function is the thing that our program actually runs, and it's going to open and close its own set of curly brackets here. The curly brackets is something we're going to see a lot. And everything inside these curly brackets are the actual instructions that our program's going to run. So it's going to go piece by piece, and it's going to say, I'm going to run this, and then I'm going to run this. This thing here, printf, is something that will actually send text to the terminal, and it's going to actually print out this thing called hello world. We've got this interesting symbol here called /n. Because when we're sending text to the terminal, sometimes we want to give it the enter key so that it will drop down to the next line. That's what this /n is. So anytime I put this /n somewhere where I can send text to the terminal, instead of this /n appearing, it presses the enter key in this terminal. Return 0 is the thing that ends the program. So return says I'm ending this main function, and the 0 is just a kind of an error code. Has anyone ever seen a 404 code when you're looking up something on the internet? So a 404 usually means that there was no file, that we were looking for something on the internet. 0 is like saying that this program has executed successfully, and 404 is one of thousands of other possible error codes we could have. So usually we return 0 if we were successful, or we might give another number if we're not successful. This is a slightly old way of doing things, so we won't even be using this that much. But I put the return 0 in there for completeness. So this code has some information for a human, some way to grab other code from somewhere else. We're going to talk about that in great detail later, but for the moment we're just going to understand that this line gives us access to the ability to write and read stuff from this terminal over here. This program runs from the start of the int main void and runs these two instructions, each one on its own line. The first one's going to print out some text. The second one's going to end the program. The program would actually end here on the close bracket anyway, but I like to have it explicit sometimes. So this is our first C program, and I'm going to show you how to make this program run. So what we're going to do here, I'm going to do an ls here, and we can see that the file hello world.c exists. If I open this in my file explorer here, COMP1511, folder lecture 1, hello world.c. So that might give you a more familiar context for how I'm navigating these directories here. So for this to run, it is not currently a program that can run. It's a piece of code that we've written that has a set of instructions for the computer. So for us to make it into something that can run, I'm going to use DCC, which is a compiler. So you can see when I'm doing stuff in terminal, everything is just written as text. So if I want to run the program DCC, I just type in DCC. And then I type in hello world.c. So what this is going to do is it's going to run this program, and it's going to give the program this file. I'm also going to say, please give me a file, an output file, which is going to be the name of the program that I create. So if I do -o and I call it hello, it's going to create a file called hello. I can optionally just do this without the -o, and it just makes a generic file. I'll run it with the generic file. So what that has done is it has now read everything that's in this file, converted it into a program that can run. If I do ls now, there's now this thing called a.out. I usually don't use a.out, but a.out is a program that I can run. What I will usually do when I DCC is I'll say hello world.c. So this is me saying compile this program that I've written. And if I do -o and hello, what that will do is say, okay, I would like you to create a file called hello, which is this hello world.c compiled into a runnable program. So if I do ls now, I have all of these files here. I'm actually going to be concerned with this hello here. This is the file I was editing, hello world.c, and then hello is the program that was created after I compiled this file. So hello is no longer human readable. It's not something that I can understand if I was to look at it, but it's something that the computer can say, okay, this is a really specific set of instructions that I'm going to follow. So I can run this program hello by typing /hello. / just says I am going to run something in the directory that I'm in right now. So I need to type that so that hello will actually run. I mean, when I consider it like this, that would be the same as me double clicking on hello and then getting it to run. The / is like double clicking on something. So I'm going to press enter on that. /hello says hello world. There's a lot of people having conversations in there. I think nearly everyone who was answering the questions before the tutors have gone to actually teach their tutorials. Hopefully, if you're in their tutorials, you've gone to the tutorial already. Rosie's asking if we can use GCC instead of DCC. Yes, but I would recommend using DCC on most everything that you're going to submit, because DCC has a whole bunch of stuff added to it that we've added to the compiler. GCC is a compiler that professionals use because they know well enough what they can and can't do. When you're a student and you're just starting out, there's a lot of things that you probably shouldn't do with code, but you can do with code. So DCC is kind of like something with a whole lot of safeguards on it. So every time you do something that's a little bit weird, DCC is going to say, hey, that's a bit weird, are you sure about that? So it's a lot more helpful than GCC. GCC will just do whatever you want. So you say, I would like to delete everything on my computer, GCC will be like, it'll just do it. Not exactly that, but in that kind of vein. Whereas DCC will say, hey, are you sure about that? I think that you don't want to do that. And here are some suggestions about how this might work. So DCC is a lot friendlier for learning how to do things. So I would suggest using DCC. It is reasonably hard to install DCC on your own computer, but if you're logging in via VLab to do things, DCC is really handy. There's a lot of people here who have done a lot of programming before, by the looks of it. So, oh wait, there was a question there about why am I using the hash include standard input output? It's basically because I don't want to have to write the code to print something to the terminal. It's reasonably complex and it's kind of a solved problem, which is why I'm using something like the standard input output library is what it's called here. Because I want to get people to the point where they're just doing simple code and thinking about what's important about the code, not having to do a whole bunch of setup beforehand. So I'm just using someone else's setup in a sense. People are asking whether it's important which compiler and text editor to use for the course. Not super important which ones you use. I'm always going to be using gedit and DCC. So if you want the easiest road through this where you can just use my examples exactly, then I would use gedit and DCC over VLab to connect to our systems. I understand people are in all parts of the world. VLab is a virtual connection to our computers here in Sydney. So if you're having trouble with that and it's getting laggy and things like that, then maybe you do need to set up something so you can program locally on your own computer. Okay, I should wrap it up because I've gone way over time. I'm going to go back to my slides. So I've got details here in all the slides if you want to look at them. And this is just everything that I've been saying, but in text detail if you want to go back to the slides and look over it, the compilation and how to run it and things like that, similar to what I just did. And so this is where we're at the moment. So we have one working program and we were able to run it under the Linux system. So there's just a few little things to learn. You can go back through the slides and try to recreate it yourself. So that's what I would suggest doing. Try running this yourself. Try getting VLab running on your own computer and getting that going. If you want to, you can just wait until the labs this week, because in the labs this week, it's very similar stuff to what we're doing here. Your tutors will teach you how to get VLab set up as well, because I think you're going to want some kind of programming environment on your own computer to be able to do this course. Whether that's a connection to our VLab and then you can just copy exactly what I do, or whether it's getting a programming environment set up on your own computer, that's up to you. Someone's asking you about bandwidth. I am using... Oh, you're doing speed test inside VLab. I think if you're doing speed test inside VLab, you're finding out how fast UNSW's internet connection is. And UNSW's internet connection will be really, really fast at the moment, because there's very few people actually working there. Usually that would be burdened. Anyway, what we did today, I apologize for going a bit over time. I hope I haven't interrupted too many people's labs and tutorials. So we talked about COMP1511, we talked about how the course works, we talked about how to find help, and also talked about what your responsibilities are going to be in this course, and a little bit about how we're going to learn about programming. We looked at some of the history of computers, which I thought was some fun trivia that's really handy to know, and a brief overview of how they work, and an introduction to our first C program. We're going to go over all the details about how to program in C again on Thursday and in the tutorials and labs, because these are the basics that we want everyone to be able to get. So I've gone over them quickly. You'll get more time to look at them in the labs. So we did have our very first C program. On Thursday we're going to give you a bit more stuff about how programming works and then write another program. But I'm going to wrap it up here because I'm already quite over time. So hopefully I haven't interrupted too many of the tutorials that are running right now, and people have actually left to go to those tutorials. There's a few questions here though, so I'm going to say that this is the lecture over, but I will stick around and answer a couple of these questions before I actually turn off the stream itself. So we had some questions here. People asking about Visual Studio. I'm pretty sure you can use Visual Studio VS Code. I think we've even got that on our computers if you want to. I'm not using anything like that because what I'm doing, the way I'm teaching this, is I'm going to keep it as stripped back as possible. So I'm going to teach you with the minimal amount of stuff necessary to learn how to do things. Oh, it's sad because the world never hellos back. We can say hello to the world though. Someone's asking what the -O hello does. So let me go back. So if I did DCC hello world, which I did here, it creates a generic file called a.out. Sometimes I don't want the generic file a.out. Sometimes I want to actually name something. So -O says output. It's a -O is actually short for output file, and I'm saying I want the output file to have a specific name, so I've given it the name hello. Often people will name the output file the same thing as the C file, just without the .c. So it's like the .c is the code for this particular program. So The -O just says, I want to create a particular file. So you can see the name is the same there. Ronan saying, gedit and DCC, we're using DCC here, not GCC, look old as hell. Yeah, we are. We're doing old school stuff here. I mean, there's a reason why we're doing C as a language. C is a really good language because it's one of the precursors to the majority of modern programming languages. I mean, if anyone's done any stuff in C#, C# is directly descendant from C. Java and all the Java derivatives are also directly descended. Well, not directly, but based on the way C works. So that's why I like it as a first language. Not only that, is it's really interesting to learn because it allows you to have more control over your computer than most other programming languages. So yeah, it does look old, but this is the way that we actually dig into the back end of the computers. So it's worth learning about, because heaps of systems are going to run on stuff like terminals. And also, the editor is super clean. It's just a text editor, so no bells and whistles. So we're going to go into the purity of, like, it's just us and the code. You know, there's no freebies, there's nothing doing anything for us here. Is hash include like Python import? Yes, it's very similar. It's like it grabs another piece of code and it gives your code access to that other piece of code, which I'm pretty sure is what Python import does. My Python's super rusty. I haven't done Python in years. I'm actually a C++ native speaker, which is very similar to C. Again, another language that is a descendant of C. People are answering each other's questions. Why is a.out necessary? A.out isn't necessary. I was showing you two different ways of doing it. So two different ways of creating a file from a piece of code. I prefer the -O because it's easier for me to remember what I'm working on if it has a name other than a.out. A.out is just a default name, and so I prefer not using that most of the time. The question, there is another question though, is why is an executable necessary? So, interesting thing here. Some programming languages will work with this file. So they will actually read the code as they run it. C is what's called a compiled language, where this file here gets translated into something that the computer understands that humans don't. So compiled code sometimes has the advantage of not having to read and interpret this code as it's running, so it can run faster. It won't always run faster, but in general, compiled languages are made so that you don't need the code anymore. Like, you've written the code, you've translated the code into a program, the program then gets sent off to other people to use, and things like that. So it doesn't have the added overhead of having to keep the code and having to reread the code every time you run it. It's already been translated into something that's more directly accessible by the computer. There's not much to say that something has to go one way or the other. So some languages are compiled and some languages are what we call interpreted. You can use them either way. What is the /n? I'm still fuzzy on what that is. Be sure. Sorry, my pronunciation's pretty bad in Chinese. I was asking about that. So the /n is just like if I come here into the terminal and I press the enter key. The enter key moves me down to a new line. /n is actually called new line. I'll show you the difference. So if I get rid of the /n, I save this, recompile it. Oh, I'm using a trick here. So you see how these lines are just appearing, and they're the lines I've typed previously? I'm using the up and down arrow keys to get to these for free. This is my way of recompiling things without having to retype in what I've done before. So if I compile this now, it's going to overwrite that hello file with my new program, which is the new one here that I've just edited. If I now run this, see what happens with the hello world. The prompt for me to continue is now right next to the hello world, not on the next line. So the /n is like pressing enter here and putting a line gap between these two. And if I don't have it, I don't have that line gap. So the /n is just my way of saying, okay, this is the line is finished, go to the next line. So I'll put my /n back in there. Is in hashing. Ooh, oops, I scrolled too far. Ooh, there's been a lot of talk since where I was up to. New line questions. Is hash include like a library or something? Yes. Hash include includes a library. I'm not going to go into too much more detail on that, but yeah. Ray has a hash include basically takes the code from another file and basically pastes it over that line, so it runs all that code before getting to our main here, or compiles all that code before getting to our main here. There's a lot of people who seem to know a lot about programming already here, so happy to have you here. Glad to see. Mingji Lee is asking, will the lab give more detailed information? Yes. It will give more detailed information and we'll have more time to go through these things. So in the lab you'll actually learn how to get set up and we'll have a few programs that you will be able to work around. Yeah, don't worry if it's confusing for now. This is not the last time we're going to look at how to do this kind of setup and get going. So we're going to repeat this a couple of times until you're comfortable with it. And if you're not comfortable with it by the end of this week, after the next lecture and stuff like that, we'll have some help sessions next week, or you can contact your tutor and ask them for more information. I really wouldn't ever need to fully understand what I'm teaching in the lectures until after you've had your tutorial and lab the next week and we've really gone over it in detail. Someone is also asking if the labs and tutes will explain how to set up VLab and gedit. Yes. So we've got a lot of information in those. Your tutors are going to take you through that and hopefully help get everyone set up in VLab if we need to. Someone's talking about writing BASIC on a Commodore 64. That is super old school. Oh, Callum there is asking about installing DCC on Ubuntu. I think that DCC is available. I don't know how much support there is for it, but DCC is available on GitHub somewhere. I don't have a link for it right here. But ask your tutor about it. They might know. They might even not know, because they might be too used to using CSE's computers. But there's definitely a way to get it. Jet's asking about, are the command line things going to be explained as well as the code in the text file? Yeah, hopefully your tutors will go through everything they're doing on the command line nice and slow so you can see what's happening. I'm also going to try to explain the command line stuff every time we use it as well, because it is a slightly different way of doing things. It's very like, I'm quoting a 20-year-old movie here, but like in The Matrix, how they go, oh, we just look at the code and we understand it. Command line always feels a bit like that. So there's a lot of stuff that either has to be memorized or has to be looked up while you're using it, but once you get a handle on it, then you'll be happy. You'll be happy to do some basic tasks in it. Terry's asking stuff there. I think I've answered that already, that I was just doing two different ways of doing it. Easton Wong's asking about using DCC on a Mac. It might work, but I'm not sure. Macs have an interface that is very similar to Linux. You can actually open a terminal on a Mac and you can run C code in the terminal in a really similar way to my terminal here. It's really funny, actually. My terminal's still set up for being on a lecture theatre screen, so my font is gigantic. I probably could shrink that now that I'm live streaming and it's like on your screens, but I've gotten so used to programming in giant font. Yeah, so there are possibly ways to get DCC running on a Mac. I haven't tried it though. There are some of the tutors that are very experienced with the Mac and can help you out with that. I'd say the forum's the best place to ask those kinds of questions. There's a bunch of people calling me sir. You don't have to call me sir. We're not in high school anymore. You can call me Mark. I'm okay with you calling me Mark. I had some people calling me professor previously, but professor is an actual job title that I don't have. I'm just a lecturer. It's always funny. There's a hierarchy at a university. Do I recommend using VLab or setting up your own programming environment? I generally recommend using VLab because what that means is you get access to our environment, which means you can run tests on your code that we provide. It's also backed up very safely, much safer than just a personal computer is. So I would suggest using it. However, it depends on your internet connectivity. So if your internet connection's not liking it, then it's going to be annoying to use it because you're going to get delays on your typing. So see how it goes. I would suggest it because it's the environment most integrated into our environment, so you get access to all our teaching stuff. Otherwise, you're constantly copying things back and forth to test them. So up to you. See how it goes. You can also talk to your tutor and ask about other options because there's other ways to set up your computer where some of the work is done on your computer and then some of the stuff is accessing things on our computers. So VLab is like you looking at a window into our computers, and there's other ways to do that. People are explaining to each other. A.out was the compiled C file. Someone's asking why we don't study Python at the beginning. That is a very interesting question that we could talk about for a while. I can see some advantages of studying Python at the beginning, and I can see some advantages of studying C at the beginning. One of the things that we're going to get in C that we don't get in Python is direct memory management. And we actually spend a fair amount of this course working on direct memory management. Sorry. I don't usually go for the full 3 hours like I'm going today, but I figured I'd stop and answer people's questions if people are sticking around. I would always do this in the lecture anyway. Sometimes I'd stay for a whole hour after the lecture just hanging out with anyone who had questions afterwards, which is why this stream is still going. I should say that the official content's long over. I'm just explaining things to people now. But yeah, so we're talking about the difference between whether we would study Python or C at the beginning. I think you can learn to program quite happily by studying Python as your first language. But the way that we're doing this is we're preparing you for a whole lot of rather serious stuff in programming. And to do that, C is slightly more effective because C allows us to actually allocate memory. This is something we're going to learn about later. We'll get into this in about a month, week 4, week 5, from there onwards. So the ability to directly address memory and directly allocate memory gives us the ability to build our own custom data structures and things. So it gives us a slightly closer look at the genuine sort of back end of how computers work. I think that's my best kind of rationale behind using C instead of Python in this course. We're going to be looking at this sort of deeper theoretical detail, not even theoretical, deeper practical detail about how we build stuff using computer memory. And I think that that's worth something. I mean, if someone was to tell me that I needed to teach the very first programming course in Python, and we would shift a lot of the stuff about direct memory management into a later course, I would say, yeah, we could work with that. So I would accept an argument either way, that Python could be a first programming language and C could also be a first programming language. So yeah, I don't have a super strong opinion either way, but we are set up this way to teach C first so that we can teach a lot of stuff about the details of computer and memory. Ken's asking whether GCC is okay to use for practice and working on assignments. I wouldn't. If you use GCC in a particular way, you'll get some usefulness out of that. So you can use GCC with dash. I'll show you the command. Actually, I wonder if we've got GCC here. I'm pretty sure we do. Do we? Yes, we do. So I could, if I wanted to hello world.c, I could use GCC, but if I'm going to use GCC, I would probably use these two flags with it. I can use -o as well for hello. What these things do is they say show all warnings. So -w is warning all, and -warning error saying show all warnings and turn all warnings into errors. This makes GCC a lot safer. So I would nearly run that command every time I use GCC if I wasn't going to use DCC, and I would get some more safeguards in place. I wouldn't get the kind of information that I get out of DCC. DCC actually goes to the trouble to tell you a bit of diagnosis of some of the errors. GCC is just going to give you errors. It's not going to tell you why something's a problem or how that problem came about. DCC will actually try to tell you that. So there's a difference there, which is why I would use DCC. Someone else is saying they have a Mac and they're using DCC, so obviously they've been able to install it, I guess, so Liv has a way of installing it. I'm not sure if you're using a Mac and VLab or a Mac and you've installed DCC, so there should be a way. And Ray's suggesting that, yeah, VLab gives you access to our computers. It makes it easier for us to help you as well, because we can actually see the files that you're using. But again, it's a matter of whether it works over your internet connection or not. There's an ongoing discussion about A.out and stuff. Maybe I should never have shown you A.out, but I just want to show you that it can happen. Tiger VNC works on Mac, which means you can access VLab. That's the details of the setup. You can get into that as you go. And Ronan's saying that A.out and hello were kind of the same file. It's like the same program with a different name. Yeah, Terry's getting it now, which is good. I don't know how far behind I am because I don't have timestamps on at the moment. Yeah, and Charles is explaining to Wellington there that you can get some information on WebCMS. We do have some information on WebCMS about how to set up home computing with several different options. Xena is asking whether I recommend we take some online Python as well. That's a tough call. That would depend on how much of your brain is spare. So if it's taking all of your brain power to focus on learning C and COMP1511, I would not muddy the waters by trying to learn a second language at the same time. I usually learn a second language, well, I don't say usually. I would usually teach a second language after people had gained a certain level of mastery over the first language, and then they can translate the ideas into another language. Learning two at once might be very difficult. Up to you though. Like if you've done a lot of programming before and you think that this is something that you can kind of cruise through, and you'll make this decision in the first few weeks as you see what we do, then you can decide whether you want to pile another language on top. I wouldn't necessarily recommend learning two at once, though. I feel like I've missed a bunch of conversation here because I went back to answer questions. But it looks like Terry and others are working out exactly how A.out works and stuff like that, which is cool. Yeah, Terry and Charles are having a conversation here. So what I really like about this live streaming thing is like people can help each other like that, which is really cool. All right. I'm just looking for specific questions that I can answer. Oh, I accidentally scrolled past things. Someone was asking Masony 1. I don't know how to pronounce that, but that's okay. Was asking about compilation, and if you look here, I'm using this DCC command for compilation. I also have a lecture slide on that if you want to go back and check that out. This is definitely not the last time we're going to do compilation. We'll definitely look at it again. Eric's asking how much longer are the lectures usually. This is not the lecture. The lecture ended like 20 minutes ago. But usually the lectures will go exactly 2 hours. I'm going to have to make sure I rush through. I think something about being at home and delivering the lecture to a camera on my laptop is making me go slower than normal. I'm not entirely used to that as well, so what I'm going to try to do is accelerate my pace and not necessarily talk to chat as much. So at the moment, if you have a tutorial now, you should have gone to your tutorial. This is just if anyone wanted to hang around and ask me questions, which is the same as a physical lecture. I'll usually hang around outside the lecture theatre afterwards and answer questions, which is what this is. So it's kind of like a separate session that's afterwards that just happens to be recorded. Ken's asking, how did I get my terminal with colors like that? There's actually a command. So if you're on our CSE systems, we've set up stuff with 1511. There's a command called 1511 colors. And then the sets up, if you're using the 1511 setup terminal, the colors then gives you different colors for programs, different colors for directories and stuff like that. Your tutors will probably show you that. Or maybe the colors actually are just in setup as well. Tay, what is programming? Well, that question will be answered for you over the next 10 weeks, I hope. And people liking the aesthetic of the colors. I'm not sure what you're asking there, Terry. If you put /_ it prints a warning, right? I'm not sure if /_ will print a warning. I'm not sure what /_ actually does. You know what you could do? Grab this code that I've been writing, because it's available either copy-paste from the slides, or I think I actually put it in the lectures section, and put /_ instead of /n in and see what it does, because I don't even know. I think it'd be interesting to find out. A lot of stuff with code you can just experiment with. You can see if the question is what happens if I do this, my question often when students ask me that will be, well, what happened when you did that? And then they tell me it wiped their whole computer, and I'm like, oh no, unlikely to happen. Oh, Charles saying that you got DCC from GitHub, I assume? Yeah, I think we can install that. Terry's asking you about matrices. What? We're not doing matrices in this subject. Matrices are pretty useful, though. I use them a lot when we're doing computer graphics stuff. I think Charles was trying to paste links, but I don't think YouTube allows that. If you want to give other people a link, you could potentially post something on the course forums about it. Or even ask where DCC is, and one of the tutors will say where it is. Someone saying don't make the font smaller, it's easy to read right now. That's fine. I'm more than happy to continue programming with this font size. I think it's important if I'm going to be talking over it and going over it quickly, that's got to be really readable. And also, if someone's stream drops bandwidth a bit, you're going to want the font to be pretty big size. So I'm happy to leave it like it is. Liang Chao is asking about transferring files to and from VLab from your desktop. Talk to your tutor about that. There's more detail there. Also, that's the kind of question that's really good on the forums, because any question that we could answer, I would like that to be answered for a lot of people, not just answered for who's here right now. So what I would really like is that if we have answers, they go out to the whole course, and the forum's the best place for this. Terry's asking how old I am. I'm just going to say that I look a lot younger than I really am. That's how that works. Charles has some stuff there. Actually, that is probably the answer your tutor was going to give. WinSCP is a program that you can copy things back and forth. Priya's asking you about installing and running Tiger VNC. That's something that I think you should talk to your tutor about, because they're actually going to go through it with you. So there's no point me teaching it now, because it'll be in your tutorial in your lab. I think people are just helping each other now in chat. Someone, sorry, I don't, it's a Chinese name so I can't pronounce it, was asking, what does it mean to write the program in colors? Did you mean this here, this command for colors? This was just going to change the colors in my terminal so they look nice. If you're talking about this, these colors are just, like, the text is just text, but the colors help us recognize different things that we've written. Terry's asking, did I go to UNSW previously? Yes, I did. So I did my undergrad at UNSW many years ago. Okay, I think people are, we're just now talking about things. All right. I think that's enough here. I will wrap it up here. I think there's a lot of people who just want to hang out and chat now. What was my last thesis on? My PhD research was on game playing artificial intelligence. So I was even more than that. I was using large compute clusters, like lots of Amazon cloud nodes, to run parallelized artificial intelligence algorithms for playing games. So that's the kind of research that I was doing. But I've also done a lot of teaching in computer game development as well. So I have several different fields that I've played around with over time. A lot of questions here about other things. I think talk to your tutors about things. I need to wrap this up because I've gone way over times. Yeah. Someone's asking what DCC means as opposed to GCC. I don't actually know. That would be interesting. The person who wrote it is actually a staff member at CSE. So we could ask him at some point, but I don't actually know what DCC stands for. Okay, I'm going to wrap it up there, because the 2-hour lecture with questions at the end has turned into a 3-hour lecture, and my voice is actually quite sore right now. So I'm going to wrap it up there. I'll see everyone on Thursday. Thanks for coming, and I hope the first lecture was informative. All right, goodbye all.